Hey everyone, in this 2-hour digital SAT math prep course, you're going to be able to access over 50 SAT math questions and solutions, all of which are vetted in straight from the College Board question bank, so you know those are the highest quality questions on the market. The percentage of questions in the video are also based on the content domain provided by College Board, and there's a mix of easy, medium, and hard questions. And if you're looking for digital SAT English prep, we have a full video that not only has practice problems, but covers all the concepts, grammar, everything you need for the English section of the SAT. Finally, if you want to score 1500 plus on your SAT, make sure you join our free newsletter using the links in the description, where we provide even more resources. That does it for all the mumbo jumbo intro. Good luck on your exam, and let's get into the video.
Alright, so this problem says the rational function f is defined by the equation in the form f of x equals a over x plus b, where a and b are constants. The partial graph of y equals f of x is shown. If g of x equals f of x plus 4, which equation could define the function g? Alright, so first off, what we need to do is actually determine what those constants are, right? Because we can't be throwing in random numbers. And that's the entire reason they gave us this partial graph, is so we could identify the coordinate points and actually find a and b. So there are just a couple points that we want to use. This is definitely not a linear graph, so we don't want to use, points like whatever that is, right? You can't really estimate what that value is. But there are some concrete points, right? You got -7, -2 clearly right here. We've also got right here -6, -3. And let's use another point here. This one's good, -5 to -6. All right, so we got our 3 coordinate points. And what you're going to want to do now is use a regression, right? And you're going to do a regression using Desmos, as you can see below, where you basically insert a table with those coordinate points and then set your regression y1 to whatever we had up here, right? So we had the a over x plus b, and so we're just doing the same thing here. And because we called x of 1, we'll have to identify as x of 1 here as well. So we can see Desmos does the work for us. We got a equals 6, b equals 4, and therefore we know our equation now is f of x equals 6 over x plus 4. All right, so that's cool. We know what f of x is, but now we need to identify what g of x is, right? G of x is f of x plus 4. This plus 4 right here is basically a transformation of the function to the left, right? So if we're looking at our f of x function, how do we transform this function to the left 4 units? Well, pretty simple here. What we can just do is 6 over x plus 8. Right? Because you have to remember that something like x plus 2 would be a shift to the left. Something like x minus 2 would be a shift to the right. And therefore, our final answer here is 6 over x plus 8, and therefore C is our answer. How many points in the graphs of the given equations intersect in the xy plane? Well, we have the 2 equations on the right side. You can see they have the exact same slope, right? 2x. And then they have different y-intercepts. So this one's plus 10, and this one's -1. So if you were to graph this, what it would look like is just 2 parallel lines, right? So the first one go through like this, intersect at 10, and keep going. It's a linear line. The other one would come across. It's going to be intersecting at -1. And so you'll see, because they have the same slope but different y-intercepts, that means they're never going to cross each other. And so if they never intersect, that means there's no solutions to this system. And so our answer is going to be A0. The given equation relates the variables x and y. For what value of x does the value of y reach a minimum? So here, first off, this is a quadratic equation, right? And it wants us to find the value of x when y reaches its minimum. We can see that the positive coefficient in front of x squared is positive, and therefore it's going to open up that parabola. And so it makes sense that we're looking for the minimum, because the minimum here is going to be that vertex, right? And so if we're looking for the x value of the vertex, that's just the x coordinate of the vertex, and therefore we can actually use the following equation. It's going to be -b over 2a, right? This is a part of the quadratic formula, so you don't have to really memorize this if you have the quadratic formula down. But yeah, let's just solve for it now, because we have our corresponding values, right? We know that our b value is going to be represented by -14. So let's just label this as b. And then our a value is going to be positive 1. So let's label this a. So then our b value will be negative 14, but this is negative b. And so we have negative 14. There we go. And then for the bottom part, let's change to red. We know a is just going to be 1. So that should be 2 times 1 is 2. And so therefore, we will get the following. We will get, change to green, we will get 14, right? Because a negative of a negative is going to be positive over 2. And so 14 over 2 is going to be 7. And so 7 will be our x-coordinate of the vertex. And we know the vertex here represents the minimum of where y will reach its minimum. The smallest solution to the equation. So this is just straight up algebra, right? So let's just start this off, right? So I'm not going to rewrite the entire thing, but we have square root x minus 2 squared equals square root 3x plus 34. So the first thing we want to do here is get rid of the square root. So let's just square both sides, right? And so we'll bring this over, and so now we're left with the following equation. I want to write this in white. So we have x minus 2 squared equals 3x plus 24. And so now we know that x minus 2 squared can be rewritten as x squared minus 4x plus 4. And we can set this equivalent to 3x plus 34. And so now we just want to get everything on one side, right? Because then it's going to become a quadratic equation in which then we can just factor and solve for the zeros. So here, if we subtract 3x and subtract 34, we'll get the following. We'll get x squared. Negative 4x minus 3x will be negative 7x. And then positive 4 minus 34 will give us negative 30. And the important thing here is we want to set this equal to 0. And so now we can just factor this out, right? So we have x squared minus 7x minus 30. You know the drill, find two numbers that multiply to 30, or negative 30 in our case, and add to negative 7. So here we can just write x, and we just find the factor. Let's use 10 and 3. And so we can use negative 10, x minus negative 10, and x positive 3. And that will be equal to 0. And so now we want to solve for the x values, right? So we're going to set both of these equal to 0. So we have x minus 10. That was a little wonky. X minus 10 equals 0. And x plus 3 equals 0. And so we can find that x equals positive 10 and x equals negative 3. And so it wants the smallest solution to the given equation. And so we can clearly see that negative 3 is smaller than positive 10. And therefore negative 3 is going to be our answer. To the following are solutions to the given equation where a is a constant and a is greater than 30. All right, so first off, we have three possible answer choices. So a plus 1, or 29. And so what we want to do first is, well, we can just plug in these values to see if they work out, right? So these rules or solutions are really just substitutes for the value of x, right? And therefore, we can say for the first one, if we were to test it, we replace x with a. So we have a minus 29. We know a is a value greater than 30, so that's just something to keep in mind. And then on the other side, we're going to have x replaced with a. So we end up getting a minus a. And then that is going to be multiplied by x minus 29, which is just the same thing as before, a minus 29. Something interesting you'll realize here is that a minus a is equivalent to 0. And so anything we multiply here, say a minus 29, that will be equivalent to 0, right? And we know 0 is not equivalent to the left side of a minus 29. And therefore, we can rule out number 1 as an answer choice. And so anything in our answers with rule 1 in them is going to be incorrect. So A is wrong, B is wrong, and even D is wrong. And we only have one answer choice left, and therefore that is the answer of choice C. In the given system of equations, h is a constant. If the system has no solution, what is the value of h? All right, so if the system has no solution, that means the lines will never intersect. And we can see here we're dealing with linear lines. And so linear lines that never intersect are going to be parallel lines. And we know parallel lines have the same slope and different y-intercept. So in order to do that and find the corresponding values for the constant of h, what we need to do is first put these equations into slope-intercept form. So the top one right here, what we can do here is add 9y to both sides, and then we want to subtract 5 from both sides, just so we can isolate for y. So we have 18y equals 4x minus 5. And now for slope-intercept form, this will just simplify. We divide both sides by 18. So y will be equivalent to 4/18 x minus 5/18. All right, so this is our equation, right? That means what we need to do is get this equation, the second equation right here, to have the exact same slope of 4/18, but a different y-intercept. So let's see if we can do that. So we have hy equals 2 plus 4x. So let's zoom in on this slope, right? The current slope is 4, as a value of 4. Let's just ignore the x for now. So the current value of 4 is much more different versus the slope that we want, which is 4/18. So how do we go from 4 to 4/18? Well, we can do this by just multiplying 4 by 1/18. And therefore, that will give us 4/18. And so how do we multiply 4 by 1/18? Well, that's the same thing as dividing 4 by 18, right? And we know that in order to divide this 4x, the h value will have to represent that, right? So let's say h was 18, then 4 would be divided by 18 when you isolate for y. So I'll show you how this works. So if h was 18, then we get 18y equals 2 plus 4x, right? And so now when we isolate for the y value, divide both sides by 18, we get y equals 2/18 is 1/9 plus 4/18 x. And so now we have our two equations, right? We have this equation and this equation. We can clearly see that they have the same slope of 4/18, right? But they have different y-intercepts as we wanted before. So this one has a y-intercept of negative 5/18. This one has a positive y-intercept of 1/9. This is messy. But because of that, we know the constant h is going to be the letter D, 18. It says for an electric field passing through a flat surface perpendicular to it, the electric flux of the electric field through the surface is the product of the electric field strength and the area of the surface. So it says a certain flat surface consists of two adjacent squares, which I've drawn down here. It says in meters of the larger square is 3 times the side length in meters of the smaller square. So we have represented this by x for the smaller square and then just 3x for the side lengths of the larger square. So it says an electric field with a strength of 29 volts per meter passes uniformly through the surface which is perpendicular to the electric field. If the total electric flux of the electric field through the surface is 4,640 volts times meters, what is the electric flux in volts times meters of the electric field through just the larger square? So that's a lot of information there, but essentially it boils down to electric field times area equals the flux, all right? And you can see that they've given us the electric field strength, which they say is 29 volts per meter. So 29 is going to be our electric field strength. And now the thing with the area is we don't know what the area is, but we can solve for the area because they've given us the total flux that affects both the small and large square. So the total flux is 4,640 volts times meters, right? So what we can do here is just a simple calculation to find area of the total area. So here we can just have area, and this will be 4,640 divided by 29. So the area would be 160, meters squared. All right. So there we have it. We have the total area of the adjacent squares, but we want to find just the area of the large square because if we do that, we can multiply that by the field strength in order to get the flux that it's affected by. So here's what's going to look like. So we have the total area here, and we already have variables for the side lengths, right? So in reality here, we can just set 160 equal to
let's see, we have the first square. To find the area, it's just length times width, right? So we have x times x. So we get x times x. Then we add this to the other square, which is 3x times 3x. So you have 3x times 3x. And what we get here is x squared plus 9x squared. So those are like terms, right? So x squared plus 9x squared, that's just going to give us that's going to give us 10x squared. So now we have 10x squared equals 160, right? So we can divide both sides by 10. We get 16 equals x squared. And then we can just take the square root of 16 equals x squared, square root of x squared. And we're going to take the principal square root, so that's just going to be positive 4 equals x. So we found the value of x, and that's helpful because now, let's bring this up, we can just plug in x, we can plug in a value of 4 for x for the side length. So up here we have 3x, so now we can just have 3 times 4, so we know the side length is 12, so 12 times 12. So we're finding the area of the larger square. So the total area there is 144 meters squared. So now we have the total area of this larger square, right? And so now that we have the area, we know that because of this relationship up here, it told us that the total electric flux is going to be the product of the field strength, which we already know is a constant 29, because that's volts per meter, right? Times the area of the surface, right? So what we can do here is just very simply 29 times 144. And 29 times 144 will give us a final value of 4,176 volts times meters as our final answer. So this is a very common percent problem that you might, get on your exam. So it says the result of increasing the quantity x by 400% is 60. What is the value of x? All right. So first off, let's just write a mathematical equation to represent this scenario. So we have x, that's our starting value. We're increasing the quantity of x by 400%, right? So we're adding 400% of x to x. So we can just represent this by plus 4x. And we know our final value will be 60. And so in reality, this will just be 5x equals, it's not letting me write today, 5x equals 60. Therefore, solve for x, that's going to be 12, right? So another way you could think about this is that if you increase the quantity by 100%, you're doubling it. So if you increase it by 200%, you're tripling it. And therefore, in reality, by increasing the quantity by 400%, you're really just multiplying the original value by 5. And so 60 divided by 5 is 12. And yeah, that's an easy way to think about it. Adam's school is a 20-minute walk or a 5-minute bus ride away from his house. The bus runs once every 30 minutes, and the number of minutes W that Adam waits for the bus varies between 0 and 30, which the following inequalities give the values of W for which it would be faster for Adam to walk to school. Right, so the first thing to notice here is that for all of our inequalities, everything on the right side is a constant 20, right? So that represents that 20-minute walk that Adam has the option to take. Everything on the left side, therefore, represents that bus ride. So it's the 5 minutes of the bus ride from his house to the school, including that waiting time from between 0 to 30 minutes. So if we want the inequality that shows that it's faster for Adam to walk to school, that means that 20 minutes is going to have to be less than whatever's on the left side, because then that shows that it takes less time, right? So first off, we can eliminate 2 answer choices because these don't show that relationship. So the first one is A, and then the second one is C, right? These show that 20 is greater than the left side, which we don't want. And now we're down to B or D. Well, the thing with B is it shows W minus 5. In reality, this doesn't really make any sense because that 5-minute bus ride is included in the waiting time, right? So the waiting time here is W, the amount of time that Adam has to wait for the bus. And so we want to add on that 5 minutes because it takes 5 minutes to actually get on that bus from his house and actually arrive at school. And therefore, it can't be minus 5 because we're not taking away time, that's just adding time to him. And therefore, our answer is going to be choice D. Shipping service restricts the dimensions of the boxes it will ship for a certain type of service. The restriction states that for boxes shaped like a rectangular prism, which I've drawn one out here, it's a pretty good drawing actually, the sum of the perimeter of the base of the box and the height of the box cannot exceed 130 inches. The perimeter of the base is determined using the width and length of the box. If a box has a height of 60 inches and its length is 2.5 times the width, which inequality shows the allowable width x in inches of the box. Alright, so first off, let's label our diagram, right? So we know the height they give us is 60 inches, so let's just write 60 out here. Oopsies. There, 60. And then they also give us the width, which is x. Well, we don't really have a value for x, so we'll just label x out here. We know the length is 2.5 times the width, so we just write this as 2.5x, right? And now what we need to do is set up our inequality. So let's use green and write out 130, because it cannot exceed 130, right? Therefore, I'm going to write up the sign like this, but it can be equal to 130. It just can't exceed 130. All right, so now we need to find what the restriction actually is for that 130 inches, right? Well, it says right here, it's the sum of the perimeter of the base of the box and the height of the box. And so the height of the box, first off, we have a value of 60. So we have 60, and it's the sum. So we're going to add this to whatever we have with the perimeter of the base of the box. So the perimeter of the base of the box is just that base, that one side, right? So that one side, we're going to have that length and that width. However, there's that other side. I'm trying to make the drawing. So this is a three-dimensional object. So you have two widths in reality, right? So you have a width on this side right here, and you have a width on the other side. And the same thing with the length, right? So you have 2.5x on one side and 2.5x on the other side. And therefore, when we write our inequality to find the perimeter of that one, side, we can just double the addition of both the length and the width. And so we can write this as 2 times 2.5x plus x. All right, so now what we want to do is just expand this out. So 2 times 2.5x will just give us 5x. And then 2 times x is going to be 2x. And so we get 7x over here. So in our equation, we're going to have 60 plus 7x, and that is going to be less than or equal to 130. And now we can just solve for x, right? Because x is going to be that width that we're trying to solve for. And so we can just subtract 60 on both sides, and we get 70 is greater or less than 7x. Divide both sides by 7, and we get x is less than or equal to 10. So we get this inequality over here, and we want to match it up to the answer choices. So let's look at our answer choices. So for A, we have x is greater than 0, but less than or equal to 10. Well, that actually lines up exactly with our equation, right? For all these inequalities, the minimum or x has to be greater than 0, which makes sense because you can't have a width of 0, right, for a box like a rectangular prism. And therefore, since this part of the inequality matches up with what we have down here, it's the same thing but flipped, our answer choice is going to be A. Ben is working this summer as a part of a crew on a farm. He earned $8 per hour for the first 10 hours he worked this week. Because of his performance, his crew leader raised his salary to $10 per hour for the rest of the week. Ken saves only 90% of his earnings from each week. What is the least number of hours he must work the rest of the week to save at least $270? So first off, let's just set up our inequality, right? So he needs to save at least $270, right? 270. And so he can save more than 270, but he needs to save at least 270. So greater than or equal to, and then his savings, it says right here, he saves only 90% of whatever he earns, right? So whatever we have with his $8 per hour or $10 per hour for X amount of hours, right? All that is going to be cut down by 90%. So we can write a 0.9 on the outside and then a parentheses for all of our values on the inside, right? So the first thing we want to account for is his initial 10 hours that he worked. So he worked that initial 10 hours at a rate of $8 per hour, right?
And therefore, since he worked 10 hours at $8 per hour, he made $80. So we just write a flat $80 right there. But then his performance increased, right? And therefore his salary also increased. It says his crew raised his salary to $10 per hour. We don't know how many hours he's going to work at $10 an hour, but we know that he must work a certain amount of hours to make at least $270. To save at least $270. Therefore, we can write this as plus 10, because that's the flat rate. And then we can just write X as the number of hours he works. And X in our case, in this inequality, will represent the least number of hours he must work to save at least $270. All right, so now we just want to simplify this inequality, right? So 0.9 times 80 is going to give us a value of 72. 0.9 times 10x is going to be plus 9x. Set this equal to greater than or equal to 270. Okay. And so we want to subtract 72 from both sides because we're isolating for x. And so we get 198 is less than or equal to 9x. Divide both sides by 9 and we get a value of 22 is less than or equal to x. All right, so what does this represent? Well, this means that in order to save at least $270, they will have to work, or who's there? Ken will have to work at least 22 hours, right? But this also means that, if he works greater than 22 hours, he'll save more than $270. But we just want to find the number of hours that it'll take him to save at least 270 hours, working the least number of hours, right? And the least number of hours in our case is right here, 22 hours, because that's the minimum that he has to work. And therefore, our answer choice is going to be C. Intersecting lines R, S, and T are shown below. What is the value of X? Well, they give us two angle measures, right? We have this 106 degrees out here and 23 degrees out here. So the first thing you want to take note of is supplementary angles, right? So because this 106 degree angle is on this line S, this missing angle here, which actually represents this triangle, that is going to mean that 180 degrees minus 106 degrees is going to be equal to this missing angle. And so we can pretty easily just do 180 minus 106, and that will give us a value of 74. So we know this angle right here is going to be 74 degrees. And now we have two angle measures of a triangle, and so we can find the missing angle measure, right? So this angle right here at the bottom. And so we just do 180 minus 23 minus 74, and we get a value of 83. So because this side right here, or this angle, is 83 degrees, that means we can also use supplementary angles again to find the value of X. Now why? Because we have two angles lying on the line R, right? So any two angles on a line will be equivalent to 180 degrees. And so here we're going to just do 180 minus 83 and get our value of X, which is going to be 97 degrees. And yeah, that's how you see. O is the center of the circle above. And the measure of angle OAB is 30 degrees. All right, so that's going to be 30 degrees right there. Boom. If the length of line segment OC is 18, so this is 18, what is the length of arc AB? So I think this is the minor arc of AB right here. Well, the first thing to note here is that OC represents the radius, right? Or the radius. So because OC is the radius, right? Because it goes from one point on the circle to the center, we know that the radius has a value of 18. Now the same thing happens from B to O, and as well as A to O. And therefore we know that the sine length of AO is going to be 18. So let me write. Is 18, and the sine length of BO is also 18. Now here's what's interesting, right? Because these two sine lengths are equal, right? We know they're opposite angles. The angles opposite to them are also going to be the same, right? And so if this right here, the 30 degree angle is opposite of 18, we know that this angle right here is also going to be 30 degrees. And it's kind of funny because now we have a isosceles triangle, right? So it works out in the end. So this angle right here we can conclude is 120 degrees. Boom. All right, so now how do we actually solve for the length of AB, right?
Well, here's the thing. We know that AOB, that angle, the 120 degrees right here, that is the inscribed angle of the arc of AB. So technically speaking, the length of the arc is 120 degrees. However, we want to express it in first off radians, and also it'll be based on the circumference of the circle, right? So first off, let's just find the circumference of the circle. So the circumference of a circle is equivalent to 2 pi times radians. And therefore our radians, the radius, not the radians. So the radius is equivalent to 18, right? So we can just do 2 times 18 is 36 pi. And so that is our circumference, all right? And so in order to calculate the length of the arc, what we can just do is first just find the ratio to scale it up. So we have 120 degrees over 360. So that in reality in itself is just 1/3, right? So what we want to do is just take 1/3 of that circumference. And so 1/3 of that circumference, which we know the circumference is 36 pi. So 36 pi, let's just divide this by 3. Because we know that this angle represents 1/3 of it. And so we can just do 36 over 3, which is 12, and keep the pi, so we don't have to simplify it completely. And so our final answer here is going to be an answer of 12 pi, and let's see, it does match up with answer choice B, and therefore that is our answer. So it says a rectangle is inscribed in a circle such that the vertex of the rectangle lies on the circumference of the circle. All right, first let's just draw this out, right? So the first thing you have to do with these geometry problems is interpret them. And, there's all this weird wording there, but as long as you just take it step by step, word by word, you'll be fine. So the rectangle is inscribed inside of a circle. So I'm going to draw a circle and then draw a rectangle. So the rectangle is drawn such that the vertex, or each corner of the rectangle, lies on the circumference of the circle. So what it's going to look like is one corner goes there, boom. And then the corners of that rectangle are going to be on the circumference or the outside of that circle. So there's our drawing. It says the diagonal of the rectangle is twice the length of the shortest side of the rectangle. All right, let's draw that in. So the diagonal, which is going to look like this, just going across from one corner to the other, is going to be twice the length of the shortest side of the rectangle. So this right here is our shortest side. And so let's just label that X. Let's call that X. And it's twice the length, so we can call this 2X. Therefore, that is twice the length. The area of the rectangle is 1089 times square root 3 square units. What is the length in units of the diameter of the circle? All right, so the diameter of the circle, right, is just its radius times 2, because that's just from one end of the circumference to the other end of the circle. And you can see that the diagonal actually, satisfies that condition. And therefore, the diagonal of this rectangle is that diameter of the circle. But how do we actually find our side lengths? Well, you have to use this thing on the side. That's the reference table that the digital SAT provides, right? This is provided to you. You have to focus up top on the special right triangles, all right? So if you're not thinking of special right triangles, you might be in a bottomless pit trying to solve this problem, because special right triangles is the easiest and fastest way to do this. So you can see here, for one of our special right triangles, the 30, 60, 90, we have side lengths 2x, x, and x times square root 3. That matches up with this triangle over here, right? We have side lengths x for one of the legs, the hypotenuse is 2x, and therefore we can infer that the other side is going to be x times square root 3. So x times square root 3 is going to be our final side for that part of the rectangle. And we know length times width equals the area of a rectangle. And we have the width right here and the length right here. And so we just have to multiply those together. So x times x square root 3 is going to give us the area that they provided. So 1089 multiplied by square root 3 square units. And all we have to do now is solve for x. So you can plug this right into Desmos and it'll give you an answer of x equals 33. And so now that we know what x is, all we have to do is plug it in here, right? So x is 33, so we know one of the side lengths is 33, but that diameter is that diagonal of the rectangle. And the diagonal of the rectangle is 2x. And so 2 times 33 gives us 66 as our final answer. Function f is defined by the standard form of a quadratic. A, B, C are constants. When it's graph, it passes through these points. So these 2 points, 7, 0 and negative 3, 0, these are the x-intercepts. It says if a is an integer greater than 1, which of the following could be? So could means that there are multiple possible values, but just based on our selections here with our choices, which one could be a value of a plus b? So first off, let's just write what we know. So we know f of x is our function, and a is a integer greater than 1, except we don't know what it is, right? So let's just write a to represent it. However, what we do know are the roots, and that is 7, 0 and negative 3, 0. So when you have these coordinate points as solutions, you can rewrite them in their factored form. So 7, 0 can be rewritten as x minus 7, because when you set this equals 0, you solve and get positive 7. And negative 3, 0 can be rewritten as x plus 3. Right, that's interesting. But now to actually expand this out and actually get a value for b, what you might realize here is that we need to actually have a value for a, right? So it says a is an integer greater than 1. Well, what's an integer that's right above 1? Well, 2. So let's just have a value of 2 for a. So then we have 2 times x minus 7, and then x plus 3. So now we can just expand this out. So let's just do this part first. So we have x squared, and then we'll get negative 4x, and then minus 21. So then we have to apply the 2 right here to the outside. So then we have to multiply this entire thing by 2. So then we get 2x squared minus 8x minus 42. Right, there we go. So it says, which of the following could be a value of a plus b? Well, which ones are a value, which is right here, a value, and our b value, right here. So our a value is positive 2, and our b value is negative 8. And if we add those together, positive 2 plus negative 8 is just 2 minus 8. That's going to give us the answer choice of A. A circle in the xy plane has its center at coordinates negative 4, negative 6. Line K is tangent to the circle at the points negative 7, negative 7. What is the slope of line K? So this is an interesting problem because when you talk about like geometry on the SAT, you don't really get too much into the obscure concepts. So we have tangent lines on a circle. This one thankfully is quite simple and straightforward, so I'll show you how it's done. So if we draw like the coordinate plane here, and we know that the circle has its center at these coordinates, negative 4, negative 6. So it's like going to be somewhere, I don't know, like right here. And we don't actually know the radius of the circle. We probably could calculate it using these points and finding the distance and stuff, but that's not really relevant for our problem, and you'll see why. So line K is tangent to the circle at the point negative 7, negative 7. And so negative 7 is out here somewhere. And so, I mean, the radius is going to be like somewhere like this. So we have that. That's a really lopsided, ugly looking circle and probably not drawn to scale or accurately. This is just a visual representation. And so line K, I'm going to draw in black here, is tangent to the circle at this one point right here, which means the tangent line is going to go through like this, because tangent lines would hit at only one point on that circle. So it'll go infinitely on both sides. And so we want to know the slope of this line. So the only way to determine the slope of this line is to use the information we already know. So we know 2 coordinate points, right? And these 2 coordinate points, only one of them are actually on line K. And so what we need to do here is actually find the slope of the perpendicular line to line K. So if we draw another line through the green line, that's a bad diagram. So we draw it through like this. Just pretend that's a straight line. You can see that the green line is going to make a perpendicular angle with line K. And so those are perpendicular lines. And perpendicular lines have opposite reciprocal slopes. And therefore, what we need to do is actually just find the slope of line K. Find the slope of the green line here, and then we can find the slope of line K. So the slope of the green line, let's draw over here, is going to be based on these 2 coordinate points. So the equation is going to be y2 minus y1 over x2 minus x1. And so here, let's just look for the change in y. So the change in y, we're going to be going from -7, -7 to -4, -6. And so the change in y, which is -7 to -6, that's a change of +1. So +1 on top. Now the change in x, so we're going from -7 to -4. That's an increase of +3. And so, right, +3. And so we know the slope of this line is 1/3, and which makes sense because if you look at the diagram, it is positive. It's going to be positively linear, and therefore a positive slope as 1/3 makes sense. So then what is the slope of line K? Well, we just need to take the opposite reciprocal, and the opposite reciprocal here is going to be -3. And therefore our answer choice is going to be A. Function h is defined by h of k equals ax plus b, where a and b are positive constants. All right, so let's just keep that in mind. The graph of y equals h of x in the xy plane passes through 0, 10, and -2, 3, 25 over 36. What is the value of a plus b? All right, so when they give you these two coordinate points and a general equation like we have here, ax plus b, let's just start plugging in the numbers and see what we can make of it, right? So h of x is just our output or our y value, and we can see here in the first one, our y value or output will be 10. So we have 10 equals, we don't know what a and b are, but we can figure it out from these values. So here it says that with the input of 0, so x equals 0, we're going to get an output of 10. Well, let's see. So a to the power of 0 is going to give us 1. So here we have 1. So 10 equals 1. So this is plus b. And so what added to 1 gives us 10? Well, that is going to give us a value of 9. So we still do not know what the value of a is, but we know whatever a is to the power of 0 is going to be 1. But we have now just found out the value of b, right? And it makes sense because b is a positive constant. Now what we want to do is tackle the second part. So the second part here is -2, 325 over 36. So let's see what we can do here now that we know what the b value is. So we know the output is going to be 325 over 36. So 325 over 36. And we want to set this equivalent to just our general form ax. So a, we don't know what that is. X here, in our case, right here it says it's -2. So -2. And we already found the b value from our previous journey up there. That's going to be plus 9. And so now what we want to do is just solve for a, right? So we can subtract 9 on both sides. And this is actually interesting because 325 over 36, 9 times 36 is going to give us 324. And so when we subtract 9 on both sides, that's in reality is just subtracting 324 divided by 36. And this will be set equal to a to the power of -2. And so if we want to solve for a here, let's simplify the left side. That is going to be 1 over 36 equals a to the power of -2. And you can plug this into Desmos and solve it, but here there's just exponent properties. So a to the -2, that is the same thing here as just 1 over a to the power of 2. And so because we have 1 over 36 equals 1 over a to the power of 2, what we can do here is just disregard everything on top because we can take the reciprocal of both sides. So this in reality really is just 36 equivalent to a squared. So now what we can do is just solve for a by taking the square root of both sides. And on the SAT, when you take the square root, when you manually take the square root of something, you are taking the principal square root, and therefore you only want the positive solution. And so instead of -6 and 6, it's just going to be +6 as our final answer. So +6 here is our answer for A, but the question is asking for the product of A and B. So we know here that B is a value of +9, and A is a value of +6. So 9 times 6 is going to give us a value of 54, and therefore C is going to be our final answer.
All right, so the next problem says a circle in the xy plane has a center at those coordinates of -5, 2, and has a radius of 9. The equation of the circle is x squared plus y squared plus ax plus by plus c equals 0, where a, b, and c are constants. What is the value of c? All right, so the thing here is we've drawn out what we have, the standard form for a circle, right? And so what we have are these centered coordinates, and we know the centered coordinates correspond with h and k respectively in this equation. And we also know the radius, so we can just plug these numbers in. And so here we'll have x, and because we have a -5 and the standard form here is a negative, in reality h here, h is -5, right? So if you take a negative of a negative, that's in reality just positive. So x plus 5 here is going to be squared plus y minus k. K here is just positive 2 squared equals the radius squared. The radius we know is 9, so 9 squared is 81. And so now what you'll realize is if we just expand this out, right? We have two parts here that we can expand out. If we expand this out, it will become eerily similar to the form we have here because we're going to break it up into the x squared, the ax, the y squared, and the y parts. So here we have x plus 5 squared, which is the same thing as just x squared plus 10x plus 25. I'm going to switch colors for the y minus 2 part. That is going to be plus y squared minus 4x plus positive 4 equals 81. And so what we're interested in seeing here is the c value, right? The c value is the constant and it doesn't have the x or x squared in front of it. And so because of that, we can actually determine what it is because on this side you can see it's 0. But on our side here is value of 81. So what we need to do is subtract 81 on both sides. Boom, boom, boom. And then once we subtract 81 on both sides, we just want to combine like terms, right? We have a positive 25 here, a positive 4 here, and then a negative 81 here. So here we just have 29 minus 81. And 29 minus 81 will give us a value of negative 54. And therefore we can determine that the value of c here is just going to be negative 52. All right, so this last question I picked out because it's sort of non-traditional, right? It's not something you're going to see often, but I think it's a really interesting problem. So it says, what is the area in square units of the triangle formed by connecting the 3 points shown? So, I mean, we have 3 points and we want to know what the area is. So let's just connect these 3 points and we can see that it's going to make a triangle. So let's just connect these points. And the thing with this is you have to realize is we're not going to be calculating like the distance between these points and then using like base times height or whatever. So what we need to do here is actually use a strategy that is common on the geometry region. So for those of you who don't know what the regions are, if you live in New York, you have like state assessments, whatever. So one of the popular problems is like you got to find the area of a triangle and stuff. And how you would do that is just enclose the shape within another shape that is easier to calculate. So in our case, we want to use a rectangle, right? So we draw this out, we can enclose this entire shape within rectangle. So there we go. So we can just find the dimensions of the rectangle, and you can see that the rectangle here has a, let's see, what is this, -3. So 7 units on this side. And then on the top, it is 8 units. So here we have 7 times 8. And so we can see that at most, obviously, it's going to have an area of 56. So what we're going to do now is find the area of each of these individual triangles on the outside using base times height divided by 2. And therefore, once we find those areas, subtract it away from 56 and we'll find whatever we're left with in the middle. So let's start off with this top triangle. So we have 1 times, this looks like, what is that, 8. So 8 divided by 2. So we have 4. So this triangle right here is 4. And let's try this one over here. So this one is 7 down. And it is, looks like 7 across. So 7 times 7, that's 49 divided by 2. Will give us, what is that, 24.5. And then our final triangle on this side, let's see, it's going to have a height of, looks like 6, so 6, and then a width of 1. So then 6 over 2 will give us the area of 3. So these are the different areas of the parts or the external parts that we want to subtract away from 56. So 56 subtract 4 is 52. 52 subtract by 3 is going to give us 49. Oops. 49. And then 49 subtract 24.5 will give us a final answer of 24.5. And therefore, our answer for the area in square units of the triangle is going to give us an answer of 24.5. XY plane aligned with equation 2y equals 4.5 intersects a parabola at exactly 1 point. If the parabola has equation y equals negative 4x squared plus bx, where b is a positive constant, what is the value of b? Alright, so first off, I'm just going to say this. You can solve this very easily with the Desmos calculator, and I'll show you how to do that. However, I'm going to show you how to do it algebraically. That way, in some cases, when College Board comes up with a question that you can't just solve using Desmos, you're not cooked, right? So let's actually solve this legitimately using some algebra. So we know that this is going to be a system, right? Because they intersect at a point. And because it's a line that intersects a parabola at exactly 1 point, we know that it's going to be intersecting at its vertex. So first off, let's just get them both set to each other. So for this top portion, we have 2y equals 4.5. Let's rewrite this as y equals 2.25, right? So now since both of these, this one up here and this right here, they're both y equals, we can set them next to each other. So 4x squared plus bx, we can now say that is equivalent to just 2.25. You'll find we'll get a quadratic, which has the actual c value. So this becomes, let's write this out, negative 4x squared plus bx minus 2.25. And so now in order to solve this problem, what we need to do is actually tap into the quadratic formula. So in the quadratic formula, there is this part called the discriminant, and that is the square root of b squared minus 4 times a times c. All right, so why is the discriminant important? Well, because the discriminant actually tells you the number of solutions that are in the quadratic. So our a value is negative 4, our b value is, we don't know, that's what we're trying to solve, and our c value is negative 2.25, right? So the thing with the discriminant is that if it is a positive value, you're going to have 2 real solutions. If it is equal to 0, you're going to have 1 real solution. And if it's negative, you're going to have 0 real solutions. So since we know it intersects at the parabola at exactly 1 point, we know that it has to have 1 solution. If this doesn't make sense, I'll clarify later when we actually show you how to do it with the graph. So right here, we can just write this out because we know the a and c values. So right here, we have b squared. We don't know what b is. We know it's minus 4. Then a is just negative 4. Oops. A is negative 4. And c is negative 2.25. So we can calculate this out, and this is what we will get. We'll get b squared minus 36. All right, so now we have b squared minus 36, right, under the discriminant. So we talked about how if the discriminant was equal to 0, there would be exactly 1 solution. So that's what we want. We want the discriminant to equal 0. So if we want this to equal 0, it's pretty simple, right? So under the square root, we just want 36 minus 36, which would equal 0, right? And the square root of 0 is 0. So here we know that b is 6, right? And b6 is our answer in this case, is the positive constant. So that is how you solve that, but I also want to show you a much easier way and also explain it a little more in case you didn't understand that explanation. So let's move over to Desmos, and I do need to adjust the camera a little bit. So here what you'll see is that what I've done is plotted y equals 2.25, right? Because it's a system, I'm setting both of the equations onto the graph, and then that y equals negative 4x squared plus bx. But what Desmos does is it reads b as a constant, right? So what you can actually do, here I'll remove this, you'll say, when you add plus bx, it'll say add slider. Now you want to click that add slider, and guess what? Now you can just move this and adjust the value without having to plot and guess and check a bunch of times. So here we have the blue is the y equals 2.25, and then our y equals negative 4x squared plus bx is going to be our quadratic. So we want to just move the slider until it hits the vertex, until our parabola hits that line, right? So if we move this over, and we can see that around b equals 6, it intersects, and the system intersects there at the vertex exactly. And so now that is a way you can easily figure out that b is equal to 6 in a matter of seconds. Now, another thing I want to point out is I want to bring this bottom graph up. So the reason in the when we solved it algebraically, the reason we did negative 4x squared plus 6x minus 2.25 is you'll notice that we were able to use the property of the discriminant to determine how many solutions it would have, because here you can see there's multiplicity, right? So there's only one real solution here at 0.75 comma 0, right? So there's one solution here. But this equation right here is the exact same thing. The black one is the exact same thing as the green one, except that there was a different constant, right? There was no constant up here in the green one, whereas this one was just shifted down 2.25 units. So in reality, we know that what we're doing is we're treating that y equals 2.25 line as y equals 1, right? In this case, with the green one, the y equals 2.25, the one solution was just there, right, at the vertex. Whereas for the black one, it's the same thing, right? Think about the y equals 0 line as just that y equals 2.25 line. And since it only intersects at one point right there at 0.750, we know it can only have one solution, right? So we can add 16 on both sides when we set it equal. So we can just skip that step and put plus 16. Boom, plus 16. All right, there we go. So what we're trying to find is the least possible value of k, so the coefficient in front of our x squared term, and the equation has no real solution. So when it is a no real solution question, or maybe it's asking, oh, if it has one solution, then you're always going to be looking at the discriminant when dealing with that quadratic. So the discriminant is just b squared minus 4ac, right? So basically what happens with the discriminant is that when the discriminant is equivalent to a negative number, there's going to be no real solution. Therefore, now that we have the values, we should just plug it in. So in our case, we know what b is. Our b value is negative 56. So negative 56 squared. Oops. Negative 56 squared. And then we're going to have our c value, which is 16. So our a value first. So our a value is k. So we don't actually know what that is, but we know our c value is 16. So this is what's interesting. Now we have everything out here. So negative 56 squared is going to give us 3,136. And this will be equivalent to, we do 4 times 16, so negative 64k, right? So this is our discriminant right now. As we said before, we want this discriminant to be negative, but it also has to be the least possible value of k, and it's an integer value, so we don't want any decimals, right? So first off, let's just find the value of k that makes this 0, right? So in our case, the square root of 0, what would make this 0? Well, k would have to multiply by 64 to give us 3,136, right? So in this case, k would then be equivalent to a value of 49, right? So if k is equivalent to 49, we would have 3,136 minus 3,136, and then we would only have one real solution. But in our case, we want no real solutions. And so we'll just take one integer value above 49, and we will get k equals 50, right? You can check this. 64 times 50, subtract that away from 3,136, and you'll indeed get a negative number. And therefore, our answer for the least possible value of k for the no solutions of this equation would be 50. Square A has side lengths that are 166 times the side length of square B. The area of square A is k times the area of square B. What is the value of k? So it's a very straightforward question. You can draw a diagram if you want to visualize it. So I'll just draw 2 squares. So let's call this one square A and this one square B. All right, and we know the side lengths are 166 times the side lengths of B. So if the side lengths of B are x, call it x. then A would be 166x. I'll just put those on both sides. And so to find the area of a square, we'll just do length times width. So if we have x times x, that will give us x squared. And then we want to set this in proportion to 166 times 166x. So what that's going to give us is 27,556x squared. Alright, so now we want to compare these two numbers, right? Because this is the area of square B, and then the one on the bottom is the area of square A. So how can we compare? Well, we can just plug in a random value for x. So let's say the side length of B was 1, right? So then we would get 1 squared. 1 squared is just 1. And then since 1 squared is 1, then we know for the bottom part, this is just equivalent to 27,556. We can clearly see the relationship here that the area of square A is 27,556 times. So ABC above is a right triangle, and sine of B is 5/13. What is the length of side BC? Alright, so pretty simple problem here, except there is a little caveat that we have to take consideration of. So first off, sine B, I've marked the angle B. We know SOHCAHTOA, which is so sine represents opposite over hypotenuse. And so the opposite side would be a side length of 5. However, the interesting thing here is that it says the hypotenuse is a length of 13 when it's clearly marked 26 on our diagram for side AB. So what is happening here? Well, basically what we need to do is scale it up, right? Because if it's something that can be condensed down, it can be, and it's still mathematically correct. But so I'll show you the case here. So in reality, our actual length is 26, right? But our fraction here is 5/13. So what we can do is scale this up for the actual side length of AC. So since 13 times 2 is 26, then we can do the same thing to 5. 5 times 2 is 10, and so AC is a length of 10. So there we go. So we know that AC is 10, and now we want to find the side length of BC. So we don't know what BC is, but guess what? It's a right triangle, and so we can use Pythagorean theorem. So Pythagorean theorem is A squared plus B squared equals C squared, right? And we know it doesn't really matter. I guess I'll call AC or A value. So we have 10 squared plus B squared equals 26 squared. Alright, so 10 squared is 100 plus B squared. 26 squared is going to be 676. And so if we just rearrange this equation, we get B squared equals 576. And if we take the square root of both sides, we can find that B is equivalent to 24, and therefore 24 is our answer, in which case that is the side length of side BC. The equation above defines a circle in the xy plane. What are the coordinates of the center of the circle? So I've written out the actual circle equation out here. You can see that our current equation doesn't match that, so we can't really base our coordinates here. So we can't take 20 or 16 or any of that, but essentially to find our coordinates, we know that H and K represent the coordinates of the center of the circle. So first off, we need to convert the top equation to our standard circle equation form, right? And the way we're going to do this is to find a perfect square trinomial, and we can do that by completing the squares. So let's start off with x squared plus 20x. And to complete the square, what you're going to do when there's not a coefficient in front of the x squared term, let's write this out, -20, is you take half the b value. So in our case, the b value for this first x squared part is going to be 20. And you can take half of that and square it. So half of 20 is 10, and you square it, that's 100, right? And we want to add it here. And so whatever you do to one side, you want to do to the other side, right? To keep the balance so you're not manipulating the actual equation here. So then we have the second part. I'll switch colors for this. Let's use blue. Plus y squared plus 16y. And so we're going to do the same thing. Take half of the b value. 8 squared is 64. So we add 64 to both sides. And so now we can actually get it into our circle equation form, because watch what happens. So here, this is going to factor out to just x plus 10 squared. All right, and then this side is going to become y plus 8 squared. And this thing over here, this computes to 144. Now it matches up with the circle formula, right? This is 144. That's messy. All right, 144. There we go. So now we can actually find the value. So we know that it can't be any of these. It can't be 20 and 16, right? So is it positive or negative? Well, in our actual equation, it's positive 10 and positive 8. Does that mean those are the coordinates of the center of the circle? Well, no. Because if we have a positive here, what that means is that h is negative and k is negative. Now, why? Well, I'll give you a quick example here. So if you have x minus, this is the standard form, it had a negative value of h, it'll look like this, right? You're subtracting a negative, which gives you a positive, as you can see here. And therefore, our answer here is just 10, 8. In the figure, line M is parallel to line N, and line T intersects both lines. What is the value of x? All right, so first off, what we have here are vertical angles, right? So they give us 33 degrees here, so we know the angle across from that will also be 33 degrees. So if we call this angle right here that we just labeled angle 1, what we can see is that angle 1, and let's call this one angle 2, angle 1 and 2 are supplementary angles, right? Because two angles that make up a straight line will be equivalent to 180 degrees. And so if we know the total between those two angles is 180 degrees, we just found angle 1, right? Then we can find angle 2. And so angle 2 here will be 147 degrees. And this is helpful because we have two parallel lines cut by a transversal. And so we have our corresponding angles. Angle 2 that we have here and I guess angle x here, they are corresponding angles, and so they will have the same angle measure. And so since we know angle 2 is 147 degrees, x is also going to be 147 degrees, and so our answer choice is D. The function f is defined as f of x equals negative 8 times 2 to the power of x plus 22. What is the x-intercept of the line y equals f of x in the xy plane? All right, so first off, the number is probably jumping out at you, the plus 22, but don't fall into this trap. You know, there's always that answer choice that they want you to pick, but it's really just a trick answer. So instead of jumping to conclusions, seeing this plus 22, it's saying, this, you know, everything else here is being multiplied and it's dependent on x. But something you'll notice here is that the y-intercept is the value you get when x is 0, right? So if we look at this more closely, 2 to the power of 0 is really just 1, right? And so 1 is going to be multiplied by negative 8. So 1 times negative 8, and that gives us negative 8. So in reality, we have negative 8 plus 22. And negative 8 plus 22 is going to give us 14. All right? So 14 here is going to be our y output when x is 0. And therefore, our answer choice is going to be A. Which expression is equivalent to 4 over 4x minus 5 minus 1 over x plus 1. So we have a bunch of answer choices here, and the first thing we want to do to simplify this for equivalent expressions is just get the same denominator, right? That way it's easier to work with, and we can actually do some arithmetic when it comes to it. So we see here that in the first term, we have 4x minus 5 at the denominator, and then for the second term, it is x plus 1. So we can do pretty easily is just find a common multiple between these two terms, and we can just do that by multiplying 4x minus 5 by x plus 1, and then vice versa, multiply x plus 1 by 4x minus 5. And by doing that, we also have to do the same thing to the numerator. So let's see how that works. So we have 4 over 4x minus 5, and we will be multiplying this by x plus 1 over x plus 1. You can see how that in reality that we're just changing both the top and bottom of the fraction, because x plus 1 over x plus 1 is really just 1. And so here we'll get 4x plus 4 over 4x minus 5 times x plus 1. And so now we'll just want to do the same thing to the other side. So here we're going to have this term right here, 1 over x plus 1. We're going to be multiplying this by 4x minus 5 over 4x minus 5. And so therefore we will get 4x minus 5 over, and then we get x plus 1. So that's just going to be the same thing. 4x minus 5, and then x plus 5. And so now we can also just look at this entire thing over each other, right? So we have 4x plus 4 minus 4x minus 5, but they have the same denominator. So in reality, this can just be rewritten as 4x plus 4 minus 4x minus 5 over all of this. So let's write it out again. Kind of tedious, but you gotta do what you gotta do. You'll see pretty interestingly is that some of the answer choices have this denominator. So we know we're on the right track here, right? So let's just evaluate the top part, right? So with 4x minus 4x, those two are going to cancel, right? So that's just going to be 0. But now in our case, we have 4 minus negative 5. So we're really just adding 5 to 4. So that's going to be 9. So you have 9 on top, and then 4x minus 5. Really messy, but whatever. X plus 1. And so we have our equivalent expression right here. And we can see that actually matches up with answer choice D, and therefore that is our answer. Cube has a volume of whatever that is, cubic units. What is the surface area in square units of the cube? All right, so the first thing to recognize here is that a volume of a cube is just length times width times height, right? We all know this. So the thing to recognize here is that for a cube, it's made up of squares, right, as the faces. The special thing about squares is that each of the side lengths are equal, right? And because of that, we know that the length has to be equal to the width, has to be equal to the height. And therefore, in order to find the actual values of either the length, width, or height, what we can do is just take the cube root of the volume, which is going to be 474, 552. And that will give us a value of 78, all right? So 78 is just the side length of each of the sides. And now we want to calculate the surface area. So for the surface area, we can just find the area of each side and then multiply by the number of sides. So we have 78 times 78. That will give us the area of one side. And we know there are 6 faces to a cube. And so we can just multiply this by 6, giving us a final value of 336,504. The function h is defined by h of x equals 4x plus 28. The graph of y equals h of x in the xy plane has a x-intercept at a, 0 and a y-intercept at 0, b, where a and b are constants. What is the value of a plus b? All right, so first off, you guys can just plug this equation into Desmos, find the x and y intercepts, their corresponding x and y values, and then add them together, right? But we don't want to endorse, becoming reliant on Desmos, so let's just solve this algebraically for fun. All right, so first off, let's start off with that x-intercept, right? So the x-intercept, as you can pretty easily deduce from this, is what value of x will give you a output of y equals 0, right? So here we can just say 4x, which is going to be our h of x function. And we want to set this equal to 0 because we want the output to be 0, as you can see right here. So here we can just subtract 28 on both sides. So we get negative 28 equals 4x. And then we'll divide both sides by 4 to isolate for x. And so we get x equals negative 7. All right, perfect. So we found the x coordinate of our x-intercept. And now we want to find the y-coordinate of our y-intercept. And so for this part, it's pretty much the same thing, but reversed, right? We want to find the y output when x is equivalent to 0. So here we'll just put 4, and then we know x has to be 0. So 4 times 0 plus 28. Well, 4 times 0 is just 0. So if you add 28 to 0, you're going to get 28 as your final answer. And so 28 will be equivalent to our y coordinate. And so now the question says, what is the value of a plus b? So the value over here, negative 7 is our a value, and then positive 28 is our b value. And so if we add them together, negative 7 plus 28, that's going to be equivalent to positive 21, and so A is our answer.
Triangles A, B, C, and D, E, F are congruent, where A corresponds to D, and B and E are right angles. The measure of angle A is 18 degrees, whereas the measure of angle F. All right, so we know that these are right triangles, so let's just draw them out. So our first triangle is going to be, looks like B and E are the right angles, so I'll just put B here and A up top. And then call this one C. And we'll do the same thing, and these are congruent triangles, so just, they're not really the same size here, but just imagine they are. All right, so E is the other right angle. All right, so this one's D, and this one's F. And let's mark those right angles in there. It's pretty messy. And there we go. All right, so let's see what's given. So they say that the measure of angle A is 18 degrees. So we have 18 degrees right here. Boom. All right, so here's the thing, right? We know that right angles are 90 degrees. So angle B is going to be 90 degrees. And so they want us to find the measure of angle F, and angle F is in the other triangle. But since we know they're congruent triangles, we know that their corresponding angle is going to be the same, right? Not only are they like similar in terms of side lengths, but they're also going to have the same angle measures. And so if we look at this corner right here, the angle of C can actually be found by just adding up the angles of A and B and then subtracting it away from 180 degrees. And the reason for that is because there's 180 degrees in a triangle, right? So 180 minus 18, well, let's just minus 90 first, and then minus 18. Boom. So that will give us 72 degrees. And since we know that C is 72 degrees, and its corresponding angle matches up to angle F, that means angle F must have a measure of 72 degrees.
It says in the given equation, B is a positive integer. The equation has no real solution. What is the greatest possible value of B? So they give us a quadratic equation, negative x squared plus bx minus 676 equals 0. So in order for us to solve this problem, we need to calculate what is called the discriminant. So the discriminant is what you're going to find in that quadratic formula. So that is square root of b squared minus 4ac. All right, so if you didn't know, the discriminant determines the number of solutions a function has, or a quadratic function has. So if this value is positive, that means it has two solutions. If it is negative, then that means it has 0 solutions. And if it's equivalent to 0, that means it has one real solution. So in order for us to calculate this, we just need to know what the this part right here, the negative 4 times A times C is equivalent to, and then just find a B value that is less than that, but the greatest possible value. I'll show you how to do that. So let's first calculate negative 4 times A, we know our A value is negative 1, times C, our C value is negative 676. And this will give us a value of negative 2,704. All right. So as we talked about before, we need to know that the value of B squared has to be less than 2,704, but it has to be the greatest possible value. So what we can do is just set B squared equivalent to 2,704. Not negative 2,704 because this has to be a positive value in order to be subtracted, right? And so now we're just going to solve for B. So if we take the square root of both sides, we're going to get B is equivalent to the square root of 2,704, which is oddly equivalent to an odd number, whole number, which is equivalent to 52. Now 52 is not our final answer, because if B is equivalent to 52, our discriminant would be equal to 0 and we would have one solution. But this equation has no real solution. And so we know that B is a positive integer. So in order for B to be a positive integer, it is just the number that is below 52. So the next closest value under 52 would be 51. And so the greatest possible value for B is 51, because if we can test this, 51 squared
is 2,601. And that is indeed smaller than 2,704. And so if you did the math there, you would get a negative value. And so the discriminant would have a negative value, meaning you would get no solution. And that would ultimately solve the problem.
The expression 3 times 2x squared plus px plus 8 minus 16x times p plus 4. P is a constant. This expression is equivalent to the expression 6x squared minus 455x plus 24. What is the value of p? So here we have two missing variables in this one equation. So that is going to make it a little bit tricky to solve. But the thing to notice here is that p is only in the values of x. So what I mean by that is you can see 3 times px, right? That's going to give you 3px. And then over here you have negative 16x times p. That's negative 16px, right? So that is all under the same x term. If we look over here, that means it's only going to affect this term right here, negative 155x, because p can be anything and it won't affect the 6x squared or the plus 24 constant. All right, so let's set up our equivalent equation, because it says this expression is equivalent to the expression. Therefore, we can set up that equation, isolate for p, and we'll be good to go. So the 3 times px is just 3p. And I'm going to negate the x's for each of them because x is in each of these equations and it's just a substitute variable. So we can just negate that. Over here we have negative 16x times p. So just negative 16p. And I almost forgot the plus 4. So p plus 4. And that is all equivalent to, we're negating the x, so that's just negative 155. All right, let's just do some distributive property. So negative 16 times p, negative 16p. Oopsies, okay. All right, negative 16 times positive 4 is just negative 64. And then we have 3p on this side. And this is equivalent to negative 155. And let's just do some simple algebra, right? We add 64 on both sides. And that will give us 91 on this side. And so now we're left with 3p minus 16p on the left side. And that will give us negative 13p. All right, and we can divide by negative 13. Boom, boom. Oh, I actually made a mistake here. It's negative 91. That makes sense because a negative over a negative. So negative 91 divided by negative 13 gives us p is equivalent to 7. All right. So our answer choice is B. The line with the equation 4/5 x plus 1/3 y equals 1 is graphed in the xy plane. What is the x-coordinate of the x-intercept of the line? So we're looking for the x-coordinate of the x-intercept of the line. All right, so the x-intercept. The x-intercept is where, let's say you graphed. I'm just going to write a random equation. So let's just say we have like a quadratic formula, right? So these, where it hits the x-axis, would be the x-intercepts, right? The zeros. And so at these points, if you were to write out the coordinates, you would have 0 as your y value, right? Because whatever x value you have, it outputs a y value of 0. And so in our case, we know that the y value in this equation, it has to be 0 if we're representing it to find the x-coordinate of the x-intercept. So then we have 4/5 x plus 1/3 times 0 is 0. So plus 0 equals 1. And now we can just solve for x, because if we solve for x, because y was 0, then that means we're solving for the input that gets us 0 as y. And this is a function. So what is x? Well, what do we multiply 4/5 by to get 1? Well, we can multiply 4/5 by 5/4, right? Because this gets us 20 on top and 20 on the bottom, and that is equivalent to 1. And therefore, the x-coordinate of the x-intercept would just be 5/5. So that is our answer. Figure AC equals CD, okay? And the measure of angle EBC is 45 degrees. So let's label that. Boom.
Okay, and the measure of angle ACD is 104 degrees. What is the value of x in degrees? So the value of angle AEB, that's what we're trying to find. So the angle of AEB. Okay, so how I like to approach, just geometry problems in general when you're trying to find an angle is just don't try and take it in all at once. Just take it step by step, break it down, see what angles you can find, see what theorems you can implement, and eventually, you never know, you might find the answer from that. So first off, they tell us that AC equals CD. So this triangle right here, triangle ADC, this is a isosceles triangle, right? Because these two side lengths are equal, then we know that these angles here, angle D and angle A, are going to be equal to each other. Because there's only 180 degrees in a triangle, and we know angles ACD is 104. I should add units. Boom, boom. It's like there's 76 degrees between those two angles. And so we can divide that in half, and we get 38 degrees. So we know each of these angles, so angle A is 38 degrees, and angle B is also 38 degrees. Okay, so that's one step of the puzzle. So how exactly can we find angle this x, right? So one way I'm looking at it right now is it's on this line right here, and we can use what's called the supplementary angles, right? Because two angles on a straight line will have to equal 180 degrees. So if you find this angle right here, angle DEB, whatever that is, if we find that value, then we can just subtract 180 minus that value, and then we get whatever x is going to be. So is there a way to find angle DEB? Well, it's actually pretty interesting because they gave us the measure of EBC, this angle up here, and we just figured out the angle of BDE. And so these two angles make up a portion of this triangle, right? So it's this triangle right here. Boom, boom, boom. Oops. This triangle. All right. So we know there is, let me just switch back. There is 180 degrees in a triangle. So if we found two of the angles, 45 degrees and also 38 degrees, then we can find the last value. And this last value, let's do some quick maths. I think that is 97 degrees. Okay, so angle E is 97 degrees. All right. All right, so as we said before, now we can use supplementary angles. So we know these two angles, this angle we just found here, 97 degrees, and angle X, together, they will have to equal, so 97 degrees plus X, whatever that is in degrees, has to equal 180 degrees. And so we can do some simple maths. 83 is our final answer. So the value of X would be 83 degrees. And I think they want you to represent it as just the value without the degrees because they already state the degrees here. And so if you're really finding X, the actual answer is just 83.
In right triangle ABC, angle C is the right angle. So it's right, we're going to draw out our triangle. It's a snazzy triangle right there. So angle C we know is the right angle. And then it doesn't really matter what the other sides are. So ABC. Cool. It says side BC has a value of 162. Let's label that. And point D on side AB, so on AB there is a point D, is connected by a line segment with point E on side AC. So on AC there's a point E. They are connected by a line segment. And it says that this line segment DE is parallel to the side BC. So DE here is parallel to the side of BC. And the value of CE is twice that of AE. So let me switch colors. So go AE here, let's just call that value X. We know CE is just twice that value, so we call this 2X.
And now they want us to find the length of line segment DE. So here we've got similar triangles, right? Because triangle AED is inside of triangle ACB. Therefore, we need to find that scale factor. So we've got 2x here and x here. So the two triangles that we're really comparing are the following. So we've got triangle AED, right? And then we've also got this bigger triangle, ACB, or ABC. So let me remove that. So knowing that, what we need to do is compare the side lengths, right? Because if we can find the scale factor, we can just use it to scale up our other values. So we know that for triangle AED, the value for AE is x. Now, we don't know the value of AC quite yet, but we can figure it out pretty easily because 2x plus x, that's going to give us a value of 3x. So we know AC now is just 3x. So now we know that since these two sides correspond with each other, we can just find the difference. So to go from 3x to x, that's a 1/3 scale factor, all right? So knowing we have a 1/3 scale factor, what we can do now is apply this 1/3 scale factor to our known value of 162 to find that side DE, right? Because side BC corresponds with side DE. So 162 here, we're going to just scale this down because 162 is the larger value on the larger triangle. So we can just divide this by 3. That's the same thing as multiplying by 1/3. And 162 divided by 3 gives us a value of 54. And therefore 54 is our final answer for the length of line segment DE.
It says the square sides are increased by 37%, resulting in an area that is equal to that of a rectangle with a 2:5 side length ratio in a perimeter of 24 units. Find the area of the original square and round your answer to the nearest tenth. So there's a lot to unpack here. The first thing I'm going to do is focus on this first part. The square sides are increased by 37%. When we see a percent increase, we're going to use the formula 1 plus r over 100. In this case, r is just going to be our 37, right? So if we have 1 plus 37 over 100, we get 1.37. This serves as our scale factor, right? So we can apply the scale factor to the side length of the square to find the length of the new side. So let's say we represent the original square side as s, right? And so then we can just apply this 1.37 to the front as the coefficient, and now we have the new side length of our new square, right? But the problem says in the next part, resulting in an area that is equal to that of a rectangle. So the area of the new square is equal to the rectangle's area. And so to find the area of a square, we just do, side times side. And all the sides of a rectangle, all the sides of a square are the same length, so we can just square this value. And when we set this equal to the area of the rectangle, which we do not know, but we do know the side length ratio in the perimeter, right? So what we can do here is actually set up as systems of equations because this is a fixed ratio, right? So then we can write this as 2x plus 5x. And what we're essentially going to do is solve for x by setting this entire equation or expression equal to the perimeter, because once we're able to find x, then we're able to actually find the length and width, multiply those together, and then set that equal to the squares area, if you can see where we're going. So I'll explain this. So we have 2x. What does this represent? Well, if you think about a rectangle has two sides, the width and the length. So in this case, the shorter side, 2, is going to be the width. So this is the width, and pretend this is the length. Right? And then we're going to set this entire thing equal to the perimeter, which is 24 units. But what is the perimeter? The perimeter is the sum of all the sides of a rectangle. We only have one width and one length right now, and so we need to multiply the entire thing by 2. There we go, and now we can just multiply everything out to solve for x. So we get 4x plus 10x. Oops, okay, just pretend that's 10x equals 24. So that's 14x equals 24, and so x must equal 24 over 14. So what do we do with this value of 24 over 14? Well, pretty simple. We plug it into 2x and we plug it into 5x to solve for the actual value of the width and the length. So 2 times 24 over 14, and then we're also going to have 5 times 24 over 14. So this will give us 48 over 14 and 120 over 14. Okay, so we have the value of our width and length, right? So what do you do from here? well, we need to find the area of the rectangle, right? So we can set it equal to the area of the square. So we just multiply these two fractions together and simplify that, and we get a value of 1,440 all over 49. All right, cool. So now we just have to solve for s squared, because we're trying to find the area of the original square. And so because s represents the original side length, then we want to find s squared, because that's side times side equals the area of the original square. So this right here expression, 1.37 squared, that's kind of, 1.37s squared is the same thing as 1.37 squared times s squared equals 1,040 over 49. So I'm going to save a couple steps, divide both sides by 1.37 squared, and then we have our answer. So in this case, s squared is equal to approximately 15.65, and you got a bunch of decimals after that, but we want to round to the nearest tenth, and therefore our answer in this case, s squared, will be equivalent to 15.7 as our final answer.
Quadratic function models the height and feet of an object above the ground in terms of time and seconds after the object is launched off an elevated surface. The model indicates the object has an initial height 10 feet off the ground and reaches its maximum height 1,034 feet above the ground 8 seconds after being launched. Based on the model, was the height in feet of the object above the ground 10 seconds after being launched. So a really easy way to solve this problem is just to use Desmos, right? I know, it's crazy. Desmos is so easy to use. The only problem here is you have to do a little extra thinking, right? It's because they don't give you all the coordinate points that you need. We do know a couple things. So we know that the initial height is 10 feet above the ground. So when x is 0, we're going to have a value of 10. So that's our first coordinate point. And they also give us the maximum value of 8 seconds after being launched. It is 1,034 feet. Now, the only problem with regression is that to use regression on Desmos, you need to have one extra coordinate point above your degree of the polynomial. So if I had a linear function, I could have 2 coordinate points and it would work. But since I have a quadratic, I need 3 coordinate points to make it work. Therefore, to find the last coordinate point, it's actually not that hard, because you have to think about a quadratic function, right? If I have a quadratic function, I'm going to draw the other axis, and then the graph is going to look something like this, right? And what we know about quadratic function is that it's symmetrical, right? So if you were to think about this as 0, 10, right? And we think about the axis of symmetry as x equals 8, we know that everything is symmetric, right? So if this is x equals 0, and then this is x equals 8, then this value over here, when it returns back to the starting value, that has to be x equals 16, right? Because this is a change of 8, and this is also a change of 8. The side of the axis of symmetry is equal. Therefore, to find our other coordinate point is actually pretty simple, because we know that this value, when it returns, has to have a y value of 10. And we already said that x is going to be 16. So we have 16, 10. We have our 3 coordinate points now, and now we just plug this into Desmos. As you can see here, just a table with the points, and we put in our regression, and it gives us our graph, right? It gives us the A, B, and C value. But the question is asking, what is the height and feet of the object above the ground 10 seconds after being launched? So since we already have the function that represents the problem, all we have to find is the value of the, what is this? The object, okay, the value of the object, or the height of the object 10 seconds after being launched when x equals 10, right? So we just put in x equals 10 here, found the intersection, we see that when x equals 10, the y value equals 970, therefore our answer is choice C. Alright, so this problem says if 4a over b equals 6.7 and a over bn equals 26.8, what is the value of n? So to help us find the value of n, it'd be very helpful for us to scale up everything, right? Because we already know what 4a over b is, that's equivalent to 6.7, so we can use that to help us compare the values to ultimately find n. So if we were to scale up this entire equation by 4, we'd have 4a over bn, and then we would have to multiply 26.8 by 4, which gives us a value of 107.2. All right, so now it's just time to simplify, right? So what value of n would make this true? Well, because we don't actually know what the value of a or b is, we have to infer that based on our given information. We know 4a over b is 6.7, and we have 4a over b in our equation. So this simplifies out to just 6.7 over, and we have our n. So 6.7 over n is equivalent to 107.2. You can rearrange this to solve for n, and we will get a value of 6.7 over 107.2 equals n. And 6.7 over 107.2 also just simplifies to 1/16th, and therefore our value of n is 1/16th. Sample of a certain alloy has a total mass of 50 grams and is 50% silicon by mass. Okay. The sample was created by combining two pieces of different alloys. The first piece was 30% silicon by mass, and the second piece was 80% silicon by mass. What is the mass in grams of the silicon in the second piece? So to solve this problem, we need to set up a system, right? So what we know now is that the first piece and the second piece make up this certain sample of alloy. And so what we can determine is that the total mass, this is pretty much the only information we're given in terms of actual mass, is that the total mass of the alloy is 50 grams. So we can write 50 equals, and now we need to create some variables. Let's create it as x and y. So what we want to define here is essentially x is just the mass, total mass, important to note, total mass of the first piece, and then y is the total mass of the second piece. But what we want to solve in the problem is the mass in grams of the silicon, only the silicon in the second piece. So how exactly do we do it? Well, we have to read in between the lines. It says that 50% of that 50 grams is silicon. So 50 divided by 2 is 25 grams. So we only have 25 grams of silicon in that sample. Therefore, we can set 25 equal to, well, what are our other given equations? Well, not equations, but variables. We have the first piece, which is 30% silicon by mass, right? So you know x is the total mass, and therefore now we only have 30% of that for silicon. So we got 0.3x, and now we've got to do the same thing for the second piece, which is 80%. So 0.8 times the total mass. All right, so now that we've got these two systems of equations, we go over to Desmos and plug it in. So we can see, guys, we plugged it in here and we find the intersection. So this is our corresponding x and y values. It says what was the mass in grams of the silicon in the second piece. Remember, we labeled y as the second piece, the total mass of the second piece. And so the total mass of the second piece here is, you can see, 20. So 20 grams is the total mass. This is the total mass, not the silicon of the mass of the silicon, right? To find the mass of the silicon in the second piece, we need to multiply it by that 80% factor, right? Because only 80% of that 20 grams is actually silicon. So 20 multiplied by 0.8 gives us a grand total of 16 grams of silicon. Therefore, B is our answer. It shows the results of a poll. A total of 803 voters selected at random were asked which candidate they would vote for in the upcoming election. According to the poll of 6,424 people vote in the election, by how many votes would Angel Cruz be expected to win? So these 803 voters are selected at random. So whatever results we get from them, we can pretty much scale them up or expect the same proportion or ratio as if it was 6,424 people. Therefore, what we want to do here is find the actual difference that Angel Cruz wins by. So 483 subtracted by 320 gives us a value of 163 votes. So now that we have this number of 163, we can't just use this number because that's only of the 803 voters. We need to scale it up, right? And to find the scale factor, we can just apply the comparison between 803 and 6,424. So 6,424 over 803 should give us that scale factor, and that's going to be around 8. All right, so if our scale factor is 8, we know that the Angel Cruz wins by 163 votes with just 803 voters. We need to scale this 463 up by 8 times as well. And 163 times 8 gives us a value of 1,304. And therefore, our answer here is going to be B. Dot plots represent the distributions of values in dataset A and B. Which of the following statements must be true? So clause 1 says the median of dataset A is equal to the median of dataset B. And that's true because both distributions here you can see are symmetrical. If I were to draw a line down the middle, you have an equal number of points here and equal number of points on both sides, right? And so if you order the points from least to greatest and then you converge in the middle, you can see like on the ends, the 10 and the 16 cancel out, all the 11s and the 15s cancel out. You're always left in the middle with a value of 13. So let me just erase all that. So we know that the first clause here is true. So it can't be B and cannot be D. Let's see if the second clause is true. It says the standard deviation of dataset A is equal to the standard deviation of dataset B. So here's the thing with symmetrical distributions, right? So when you got a symmetrical distribution, and you can calculate this if you don't remember this on the exam or something, is that when you have a symmetrical distribution, the mean and the median are the same, all right? They're equal. And so you can kind of see this in the points. You got a value of 10 and 16. Because it's symmetrical, they should theoretically not cancel out, right? But you're going to get a mean of 13, right? 16 plus 10, what is that? 26. 26 divided by 2 is 13. We have 4 points in the 11 section and 4 points in the 15 section. If we were to zoom in on one of those pairs, you got 11 and 15. That's also 26 divided by 2 is 13. You can see how here all the points in the pairs come back to the mean of 13. We know the median is 13 and the mean also is 13 for these symmetrical distributions. Now, going back to standard deviation. Standard deviation is the measure of spread in a data. So the farther away a point is from the center, you know that it is going to have a greater standard deviation. And so because even though they're both symmetrical, right, dataset A and dataset B looks different, right? It has like more points at 15, or has the same number of points at 15 and 11, but only has 1 point at 13. Whereas dataset A has a more condensed standard deviation here because of all those points at 13, and so their standard deviations cannot be the same, and therefore the correct answer here is going to be A1 only. Density of a certain type of wood is 353 kilograms per cubic meter. A sample of this type of wood is in the shape of a cube and has a mass of 345 kilograms. To the nearest hundredth of a meter, what is the length of one edge of this sample? All right, so as you know, density pretty much is the same regardless of how much you have of that material, right? So if we have a sample of this wood, the density of that wood is always going to be 353 kilograms per cubic meter. We know the equation for density is equivalent to mass over volume. And so if we are able to plug in values for density and mass, which we do have, we can solve for volume and ultimately find the length of one edge of the sample. So we know that density here is 353. I'm just going to ignore units. Mass here is 345 over V. If we solve for V here, we get V equals 0.977. So we know that the wood is in the shape of a cube. And so now we have the volume of that cube, right? And to find the length of one edge, we know that to find the volume of a cube, it's side length times width times height, right? And therefore, because we know that all sides are equal in a cube, we can just take the cube root of the volume to find one edge or side length. So the cube root of 0.977 is going to give us a value of around 0.99. Therefore, that lines up with our answer choice of B, and that is our answer. In the figure shown, lines R and S are parallel, and line M intersects both lines. So we got a parallel line cut by a transversal, so we want to be thinking about vertical angles, alternate interior angles, all that stuff. If Y is less than the value of 65, which of the following must be true? So let's just go right through it. So it says X has to be less than 150. So X is this angle right here. And because it says Y has to be less than 65, and which of the following must be true for all values of Y, we could just plug in a random value for Y. So let's just call Y 64 degrees, right? Because that satisfies that equation. And so now we know that this y right here is 64 degrees. And so the angle opposite of that, that's going to be vertical angle. So this is also going to be 64 degrees. We can see here that this 64 degree angle and angle x, these are consecutive interior angles. And so what happens is that they are supplementary. So they have to add up to 180 degrees. So you get 180 minus 64, which gives us, oops, that was real messy. Okay, 64 equals 116 degrees. So interesting note here is that 116 is greater than 115. So that does not add up with A, and therefore A is wrong. If we were to lower this angle, which we would have to, I mean, if we had like 64.99, we would end up getting what, like 115.0001, right? But let's see if B is true. So it says B says X has to be greater than 115. Is that true? Well, we know that the biggest value of Y that we can have is 65, or not even 65 because it can't even be equivalent to it. It would have to be like 64.999. And therefore, if we had 180 minus 64.999, etc., right? That would yield what is that? 115.0000, etc., 1, right? That's messy, but you get the point. So basically, we can't ever go underneath 115 degrees for X if Y is less than 65. Therefore, B is our answer, but let's just check the other answers to be sure. So it says X plus Y has to be less than 180 degrees and X plus Y has to be greater than 180 degrees. Well, we just proved it here, right? We said that if Y, we could just name it 64 degrees. Vertical angles, this is 64 degrees. We find that X would have to be 116 degrees. 116 plus 64 is 180 degrees. And so neither C or D is correct because X plus Y will always be equivalent to 180 degrees.
And the given system of equations, R is a constant. If the system has no solution, what is the value of R? So I already done some of the work here because writing with a mouse is very hard. So we just arrange the top equation into slope-intercept form. So we get y equals 48x over 102 minus 24 over 102. And we compare that to the other equation, which is stated, ry equals 16 minus 16x. So this is important because we want to know the actual slopes, right? So our actual slope here is 48x over 102. And this one over here is negative 16x. And this is important because when you talk about a system with no solution, that means the lines don't intersect. And in a system of linear equations, the only way that those two lines don't intersect is if those lines are parallel, right? And how do you get parallel lines? Well, you need the exact same slope, but different y-intercepts. So you can see here that, yeah, they have different y-intercepts, but they need the same slope, which they currently don't have. But we can give them the same slope by changing R to the correct value. Another thing to note here is that negative 16x can be rewritten as negative 48x over 3, right? That's the exact same thing as negative 16x. And now we can see the direct comparison between negative 48x over 3 and 48x over 102. So from 3 to 102, what value is that? Well, that value is 34, right? So if we get the value of 34, we can actually convert the denominator of 3 to the value of 102. Another thing here is that R, we know now, has to be 34, right? Because if we divide both sides by 34 in order to isolate for Y, dividing a fraction by 34 is the same thing as multiplying the denominator by that number. Another thing for R is that it will have to be negative. Why? Well, because this top slope is positive, right? But our current slope down here of negative 16x, that is negative, and that translated over here. We have negative 48x over 3 instead of a positive slope. And so if R is a negative number, that means ultimately when we multiply it into that denominator of 3, we're going to get a negative value in the denominator as well. A negative over a negative is a positive, and therefore we will get a positive slope there, which should work out. So let's just go right through. If we set R equal to negative 34, let's see what happens. So we get negative 48x divided by 3. So we're going to divide everything by negative 34. And that's the same thing as multiplying the denominator here by negative 34. So we'll get negative 48x over 3 times negative 34 is negative 102. So negative 102 or negative 48x over negative 102, like we said before, is the same thing as just 48x over 102. So we can see now that these slopes do line up, right? 48x over 102, 48x over 102. It's kind of messy, but you get the idea. The other thing we have to make sure here is that the y-intercepts are different, and they are vastly different, right? We got 1/6, and if we have a value of negative 34, that's the same thing as multiplying 6 by negative 34. That will give us a very small number, right? A much smaller number compared to 24 over 102. Now, that means that the value of r has to be negative 34. But that was such a long, complicated process, so there is an easier way. And that easier way is, of course, Desmos. All right, all you gotta do is plug the top equation in, plug the second equation in, have that r, set a slider for r, and just drag that point, right? Just drag this until those two lines are parallel, right? Until those two lines don't intersect, that is your value of r. That is the value of r that satisfies the equation when there is no solution. Which expression is equivalent to 42a over k plus 42ak, where k is a value greater than 0, and we get all these answer choices. All right, so what we're going to do here is pretty much just try and simplify this into its simplest form, essentially. So we get 42a. Oh, wait, actually, let me backtrack. So you get 42a over k, right? And we get 42ak over 1, let's say. And now what we can do is actually find the common denominator here. And the common denominator is very simple for this problem. It's just k, right? So this right here just stays as 42a over k because it already had k in it. And we want to add, and we're going to multiply this 1 by k, right? So we're multiplying both the numerator and denominator by k. So we get 42ak times k. And the reason we're doing that is to find a common denominator, and the k's here, k over k is 1, so it really is the same thing, right? It's the equivalent expression or form, but we just want a common denominator here because now that we have the same denominator, we can combine the numerators. We get 42a plus whatever over k. And so now we can see that k is going to be applied to this value. Now, be careful here, it's not distributive property. This 42ak, look at it as one term, right? One singular term. So this k can't be applied to the 42, can't be applied to the a, but can be applied to the k value. So now we get 42a k, and the k times the k is just k squared. All right, so now we need to factor out the greatest common value from the top. So that is going to be 42a, and 42a times 1 will give us this first value of 42a, and then plus k squared, which is going to give us 42a times k squared will give us the second value all over k. All right. So after doing that factoring, you realize that the answer choice that we got matches up distinctly with answer choice D. It's just flopped, right? This and this is flopped, but it is what it is because it's the equivalent form. Therefore, D is our answer.
A salesperson's total earnings consists of a base salary X dollars per year plus a commissions earning of 11% of the total sales the salesperson makes during the year. All right, so let's just write this out. So the salesperson is going to make a base salary of X, and he's going to get on top of that 11%. So we'll just express this as 0.11 of the total sales. So the total sales, let's just call it S. Okay. So it says this year the salesperson has a goal for the total earnings. So this value right here, the total earnings, to be at least 3 times and at most 4 times the base salary. The base salary, remember, is the value X.
which of the following inequalities represents all possible values of total sales S in dollars the salesperson can make this year in order to meet that goal. And so we just have to write our inequality out. So I'm actually just going to erase this and write our inequality. So we know that has to be at least 3 times the base salary. So 3x is less than or equal to our total earnings, and at most 4 times the base salary. So that's going to be less than or equal to 4x. All right, so now that we're looking at our answer choices, none of them actually line up, right? C is similar, right, with 3x and 4x, but it just has s in the middle, whereas we have x plus 0.11s. Therefore, in order to actually get an answer that matches up with one of the answer choices, we need to simplify this inequality. So here, very simple, we can just subtract x on all sides, and we end up getting 2x less than or equal to 0.11s is less than or equal to 3x. And now again, we want to isolate for s because you see in all these answer choices, s is by itself in the middle as the total sales. Therefore, we can just divide all sides by 0.11. So we get 2x over 0.11 is less than or equal to s less than or equal to 3x over 0.11. And we can see that this answer choice right here lines up directly with answer choice B, and therefore that is our answer. So that does it for the video, guys. Make sure you check out our other SAT math prep videos, and I'll see you in the next.
Hey everyone, today we're going to go over every single question type that can possibly be on your SAT exam. Make sure you stick around to the end of the video because we will be also covering SAT grammar. Everything that could be on your SAT will be in this video. All of these question types, everything the College Board puts on its official website is in this video, so make sure you stick it through, and good luck. We're going to start off with textual evidence. Okay, we are getting started with our first topic here, textual evidence, likely the biggest one you'll see on your SAT. Almost all 4 of these example question types you will see on test day. So what they're going to ask you is some variation of which choice is either going to best or worst support the conclusion, right? Which choice is better, which choice might weaken that conclusion, which finding might support a conclusion, which quotation might support a conclusion. These words, conclusion, hypothesis, argument, claim, they all mean the same thing. They will be used interchangeably on test day. We've got a pretty simple 3-step plan here. Okay, the first step is you got to identify their argument. This whole question is going to center on what the conclusion is, what the hypothesis is, what the claim is, right? If you can't identify that, you're not going to know how to answer the question. This is the most important step. What you're going to do then, you're going to read the answers, and you're going to read the supporting information. In other words, every part of the paragraph, every part of your passage that's not the argument. Okay. Then you'll eliminate choices that either go against your argument or that don't make sense with the supporting info. You might have a choice that sure argues the same thing, but it uses completely different evidence to argue that thing, and that's going to be an incorrect choice. Let's take a look at this example question. In a research paper, a student argues that the Soviet Union's victory in the Battle of Stalingrad, right, we're going to have a little bit of a non-essential phrase here, which is something we're going to get to in boundaries, was more symbolically important than it was strategically important. So his argument, if I could characterize that argument in just 2 words, all right, symbolically, right, symbolically, not strategically, right, 3 words there, symbolically, not strategically, okay? So, which of these quotes is going to effectively illustrate this claim? Let's see, let's take a look at this. Does this really think about symbolically? No, this is describing how the war was fought here. This is describing the Battle of Stalingrad itself. So this is not the correct answer. Let's take a look at the next one. Most scholars debate what would have occurred with the German forces attacked a more advantageous location. That's not related to this at all. This is not the answer, okay? After suffering humiliating losses west of Stalingrad, the Red Army's generals knew that Stalingrad would be the target of a major... Nope, I can already see here we're not talking about, how important it was strategically, symbolically, whatnot. Now, a defeat at Stalingrad, which bore the name of revered Soviet leader, revered means that it's probably important. This is a symbol, right? Would have yielded some important territory, but would not have significantly stunted the war effort, which means it was not strategically important. There's our claim here. Crucially, though, it would have crushed the Soviet spirit if this had not happened, right? Again, symbolically here. So we see our answer is D. And now we're going to move on. Okay, this is our last question here for textual evidence. All right, topic 2, quantitative evidence. So quantitative evidence is slightly different from textual evidence in that you'll be given some sort of graph or table. It's kind of the same idea though. Okay, it's the same choices, it's the same idea, the same question as textual evidence, and pretty much it's the same strategy. But we're going to introduce a third step here. Our third step is to analyze and to read the graph or table given. But first we read the answers and the supporting info. Okay? Often what you'll only need from the passage is the last sentence. Okay? In this case, we have a different type of question, right? This is a more difficult question, but often you only need to know the last sentence for the argument. Okay? Then after that, we just follow our same procedure as textual evidence. We're going to read the rest of the answers, we're going to analyze, and then we're going to eliminate, questions or answers that are clearly wrong. Let's take a look at that first. Which choice most effectively used data from the graph to complete this statement? Let's find the argument. Economists have long noted that in periods of economic downturn, fewer people can afford to purchase their own homes. So what is this saying in our argument here? They're saying that when economic downturn increases, we're going to have home ownership go down. So which of these makes sense? This one, immediately I can just tell you without looking at the graph, it doesn't make sense because when a recession occurs, when we have economic downturn, it's saying that home ownership did not change. Okay, this does not complete that statement, right? Because it's trying to show a pattern. Now, this is the next one. Home ownership rates fell significantly. Again, we know economic standstill, economic downturn, so it could be B. All right, let's take a look at another one. In January 4, home ownership hit its highest level. It's not really related. Okay, it's not really related. We don't know what happened in January 2004, right? The College Board is not expecting you to know what happened in January 2004. So this is not our answer. All right. Now, D, within any given year, the homeownership rate varies slightly in response to minor economic changes. Again, doesn't really relate. Doesn't really make sense that it's equally unsurprising. No, that's right. That just makes sense. But it doesn't fit in with this cycle here. What they're trying to show you here is that there's a cycle, right? That when there's downturn, people will not be able to afford their houses. Okay, and we see here in the graph that when there's downturn, people cannot afford their houses. We really didn't even need to use the graph in that question, and that's a common theme that we see at quantitative evidence questions. Always read the answer choice and figure out the description first, because you'll likely be able to eliminate a bunch of those answer choices, if not all of them, as we just did. SAT topic 3, central ideas, is one of the most important skills that you're going to want to have in your back pocket for the SAT exam. There's only 2 questions the College Board can really ask you here. They're pretty much the same thing. Which choice best states a main idea? Which choice best states the central idea? There's 3 steps for that you're going to want to keep in mind here. So the first thing, you want to read the entire passage. Of course, you cannot know what a main idea is unless you've read the entire passage and you know what the main idea of the whole passage is. As you go through, you should highlight repeated phrases or transition words that indicate that something is being supported. For example, if I had a topic sentence to start off my paragraph and then I had firstly, secondly, thirdly, fourthly, clearly all of those are kind of supporting what that topic sentence was. Probably that topic sentence or something similar to that is going to be the main idea of my paragraph. Next thing we're going to do is we're going to eliminate anything that's too detailed or too wordy. If it's too detailed, it's too wordy, it's probably not the answer because, of course, you cannot have a main idea that's super detailed. It's got to encompass the entire passage, not just part of it. Of course, if you've got an irrelevant answer, you got to cross that out. Let's take a look at an example question here. Many intellectual histories of Black Power movement in the 1960s and 70s rely heavily on essays and other explicitly ideological works as primary sources, a tendency that can overrepresent the perspectives of a small number of thinkers, most of whom were male. Historian Ashley D. Farmer has shown that expanding the array of primary sources to encompass more types of print material, like political cartoons, advertisements, and artwork, leads to a much better understanding of the movement and the crucial and diverse roles that Black women played in shaping it. All right, male, woman, we kind of see a little play here. Should note that down for sure. Okay, let's see if we go back through here. We've got overrepresenting, blah, 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 blah. All right, let's just kind of categorize this. Let's write a note here, overrepresent. Okay, expanding the array. We've got a list here. This is kind of like a transition word. Okay, and let's take a look at the answers here. So we're looking for a main idea. Before Farmer's research, historians had largely ignored intellectual dimensions. I take a look at this, I don't see the word, intellectual dimensions. I see intellectual histories, all right, and that kind of, even if that was related here, that would sort of deny question A, right? Deny question A because what they're saying is that, there were intellectual histories that were noted here. They were just all males. Okay, now let's take another one. Farmers' methods and research have enriched historical understanding of Black Power movement and the Black woman, the female Black contribution to it. I would say this is the correct answer, but we should always make sure to check our answers. Now, why do I say this is correct? Because this entire half of the thing here, right, is telling you that she's contributing to the plethora of evidence that Black women played in supporting the Black Power movement. And this first part here is detailing what it was like before, showing that she was doing some enriching. Okay, so we see here, right, we're kind of encompassing the entire passage with this answer choice. Let's take a look at the other ones. Other historians have criticized farmers' use of unconventional primary sources. Does not say that anywhere in here. We can just cross that out. Figures in the Black Power movement, whom historians tend to cite, would have agreed with farmers' conclusions about women's role in the movement. We don't see any evidence of that. Does not say that. We don't know what these people would think. They're not, they're likely not alive today, and even if they are, they're not, mentioned in this paragraph at all. So we can say that D is not the answer. That leaves us with choice B. Topic 4, textual details, is likely one of the hardest parts of the SAT. And part of this is because the College Board does not give us a specific question type. We have to figure out a formula, and I've got that right here. So why is some detail some characteristic? And that seems pretty vague. We're going to get into it a little bit more in a second, but we got this first. Let's take a look at some steps on how we can solve these types of problems. First thing we want to do is we want to skim the whole passage, especially, the portions that may relate, right, to the detail. Then we're going to match some question-related words and synonyms. So the question might have, it's going to have this detail, this characteristic, right? What are some synonyms of this characteristic that might pop up in the text? And then you want to match those, okay? The next thing you want to do is eliminate something that's general, because we're looking for a detail here. We're not looking for a central or main idea. We're looking for information on a specific part of the text. So you're going to eliminate those kinds of answer choices, and I think it's irrelevant. Then you're going to correlate the question to the text to the answer. Let's see what that means with our example question. So, until recently, astronomers speculated that Sagittarius A prime, was a mysterious object at the center of our Milky Way galaxy. It was a supermassive black hole pointing towards indirect evidence, such as the velocity of stars orbiting rapidly around the object, to support their claims. In a 2022 study that enhances our understanding of the makeup of the galactic core, astronomer Jeffrey Bauer and colleagues captured the first images of Sagittarius A region itself, observing a ring of superheated glowing gas encircling a completely dark center, which is a phenomenon only observed in the case of black holes. Why is this significant? Let's take a look. What do we see as significant? Well, enhance is probably significant. First is probably significant. Anything that's the first is, just significant. Okay, observing a ring of superheated glowing gas, that seems a little bit significant. Encircling a completely dark center, which is a phenomenon only, that's pretty significant, observed in the case of black holes. So we kind of correlated our question text here. Let's correlate to an answer. Okay. First evidence that Sagittarius A lies at the center of the Milky Way. Does not say that, because we already have speculation that we are at the center of, or we already know that it's at the center of our Milky Way galaxy. The speculation here is whether it's a supermassive black hole or not. This is not true. Now B, the image helps establish that the supermassive black holes are typically surrounded by rings of superheated gas. That's not true. This image, we already know that this is something that happens with supermassive black holes. Right? Now C, the image helps to establish evidence that stars rapidly orbit an object at the Milky Way's galactic center. We already know this. We already have the indirect evidence, so this is not correct. Now, the image provides the first direct evidence. This is significant. Again, we're kind of tying back, we're correlating our QTA, our question text answer here. All right, the first direct evidence, direct evidence, that Sagittarius A is a supermassive black hole. This is true. Okay, we are first right? We are enhancing our understanding of the makeup, but we are capturing the first images of the Sagittarius A region and proving that it has to be a black hole because this phenomenon is only observed in the case of black holes, making our answer D. So now we're going to look at topic 5, which is transitions. So there's only really one question that the SAT is going to ask about a transition, and that question is, which choice completes the text with the most logical transition? So it's pretty simple. Basically, which of these words right here is the best word to put in a blank? So it's going to ask you a question, we'll have a blank, and you'll need to figure out which one. So how can you do that? So first thing you want to do is skim what we call a sentence sandwich, and that means you have the sentence that you're focusing on with a blank, you have the sentence before, and you have the sentence after. Okay? Then you're going to determine what the function of that transition is. What is it trying to do? Is it trying to show cause and effect? Is it trying to show like a list? Is it trying to show similarities, examples, emphases, contradictions, or opposites, right? You have to figure out which one of these it is trying to figure out. And you do not need to memorize all of these. Just try to remember one or two and then see if you can find synonyms for those in your answer choices when you actually get a question. Okay, now that you know which of these is the correct thing, you're going to substitute a word that you know makes sense. So let's say that you're thinking of a contradiction and you know the word but, or you know the word however. And you're not really thinking about these words like nevertheless, nonetheless, that people don't really use as often. You're going to just put this in the blank as but. So just like pretend that the word is but, and then go look at the answer choices and find the word that's most similar to but. And that's your 5-step plan for figuring out what's the most logical transition. That is question type number 5. Alright, and now we are on topic 6, inferences. So the main question that the SAT will ask you for an inferences question is which choice most logically completes the text. Basically, which answer is the best answer that makes sense that you can put in a blank like this one. And there's a 3-step strategy that's extremely easy that you can follow. So the first thing is you want to skim all of the passage. Don't read every single word. Just kind of look over it and take note of which words are either details or transition words, as we covered in topic 5. And make sure if you see a topic sentence like this one, usually the first sentence, wheat and barley were the most important staple crops in most ancient river civilizations, definitely take note of that too. On your College Board Blue Book test, you'll be able to use a highlighter and you'll be able to use multiple colors of that highlighter so you can make sure that your answers are perfectly coordinated. So now we're going to just take a look at an example question here. Alright, wheat and barley were important staple crops in most ancient river civilizations. Archaeologist Dora Fullman argues that the absence of wheat and barley deposits in the Indus River Valley, modern-day India, before 1900 BCE suggests that prior to this time, these crops were imported to, rather than grown in, the region. Historians, however, note that several millennia ago, soil and weather conditions in the area were not favorable for preserving evidence of these grains for long periods. The fact that wheat and barley do not appear in the region's archaeological record, therefore, and then we have a blank. So let's take note of what we have up here. So we already kind of highlighted our topic sentence. Now we're going to take a look at details and transition words. So our first detail here, archaeologist Dora Fullman argues that the absence of wheat and barley deposits in the Indus River Valley before 1900 BCE suggests that crops were imported rather than grown. However, it's a transition word, however, historians note that several millennia ago, so that would have been thousands of years ago, around and before this time period, soil and weather conditions in the area were not favorable for preserving evidence, right? The fact that wheat and barley do not appear, therefore, okay, what? Well, the historians here are contrasting, and we see that because of the usage of the word however, right? Therefore, they're saying that her idea might not be true. Why? Because if soil and weather conditions couldn't preserve the evidence that there was wheat or barley, then how could archaeologist Dora Fullman know that there was wheat or barley or not? Right? So A suggests that staple grains were often imported by Indus River Valley civilizations prior to 1900 BC. No. This, therefore, is trying to prove the historians, however. A is trying to prove choice A is trying to prove Dora Fulman's point here, right? Now B says does not eliminate the possibility that these grains were grown in the Indus River Valley before 900 BCE. I would say this is the correct answer. Remember, you should always eliminate all answers before moving on to your next question, right? But this makes sense because it's eliminating the possibility, right? Because if evidence was not preserved, then they would not know if there was wheat or barley. Now, it is difficult to explain if these crops were grown. Historians believe that it's true that that soil was not favorable for preserving evidence. So it's not necessarily difficult to explain, we just don't know. So there's a possibility. Proves that pre-1900 BC staple grain deposits are not often observed in Indus River Valley archaeological sites. Well, we know this. We know that they can't really find anything because there's no way to preserve the soil, right? There's no way to preserve the evidence in the soil. We know this, but that's not related to this idea. This therefore connects to the however. Again, we're using transition words, right? And this idea here, right, is saying this. It's not mentioning this fact. This was kind of the first part of the paragraph here. And that's all you need to know for your inferences. Officially, the SAT no longer has vocabulary-specific questions, but in reality, what they've replaced them with are words and context questions. And these questions are extremely important to be able to use logic on to deduce the correct answer, so you don't have to memorize hundreds and hundreds of vocabulary words that you might never use again. So here I'm going to show you a quick strategy for how you can get these questions done. So there are multiple questions that you could be asked relating to words and context. And if you don't know, there are only a couple of questions, again, that the College Board can ask you in general in the English section, and these are the ones that relate to words and context. So here we have which choice completes the text with the most logical and precise word or phrase. Okay, and here we're focusing on words. All right. Now, sometimes they'll give you a couple words that really make sense, but again, there's going to be a main word. So here, for example, incongruities or deferences or preferences or independence, etc. Right? And then as used in the text, and this is just going to be some vocab word. What does that most nearly mean? Okay. So what they might give you here is a word that has, a bunch of different meanings, like date, let's say. You have the fruit, you have the calendar date, you might have a romantic date, etc. What does that most nearly mean? Then I'll give synonyms for the different meanings of that word. Now here's how you're going to solve one of those. The first thing we're going to do is skim the entire passage. And you want to skim the entire passage. You can get a general idea of the connotation of the passage. So what kind of tone are we striking here? Are we informational? Are we happy? Are we joyful? Are we gloomy, etc.? Then you're going to look at restatements. Now what's a restatement? Sometimes a College Board will make a statement. Let's call it Statement A. Alright. And Statement A has a blank. Alright. Now we're going to have Statement B. But Statement B does not have that blank. It is a restatement of Statement A, but without the blank. Okay? So you can find which word will correspond to this blank in Statement B and Statement A. Right? You can find out which word corresponds to that blank. And then you'll know the answer, right? You just need to find a synonym for that word that corresponds to the blank in your answer choices. All right, now you can always use context clues in our transition words from topic 5 to also help you figure that out. Now, the next thing you're going to do is you're going to eliminate some of the words. Remember, you may not know what all of the words mean, and that's okay. What you first want to do is you want to eliminate the ones that you know are wrong, okay, that you know are wrong. Or if that doesn't work, if you can't find an answer after that, then what you should do is eliminate ones that you think might be tonally incorrect. For example, if you want a positive word, something that has a prefix like on or dis or something like that, probably isn't as positive as you want it to be, so it's probably not the right answer. So let's take a look at this example question. The wide-ranging catalog of jazz trumpeter Miles Davis has garnered an array of opinions from jazz critics. Some argue that the obvious blank, Davis's early traditional bebop output and the highly experimental jazz rock fusion that would define the end of his career reflected a genuine change in the artist's musical preferences, while others contend that Davis's efforts across genres represented a shrewd response to changing commercial demands. So I emphasize the word changing here. Why? Because it appears twice, and because it seems like that's kind of forming our statement A, statement B here, right? So let's take a look, let's test our answer choices now. Some argue that the obvious independence of early traditional bebop output in the highly experimental jazz rock fusion work that would define the end of his career reflected a genuine change. Well, independence of doesn't really make sense. This, sure, this might be independent, but that doesn't really relate to this part here, okay? Incongruities between. If you don't know this word, let's just say we skip it for now, okay? What it means is differences. All right, now deference to. Some argue that the obvious deference to Davis's early traditional bebop and the highly experimental jazz rock fusion work that would define his at the end of his career reflected a genuine change. Well, deference to doesn't really make sense there. He's not deferring to anything, right? If anything, he's deferring to this because that's what he eventually switches to. Some argue that the obvious preferences for Davis's early traditional bebop and the highly experimental jazz rock fusion work that would define the end of his career reflected a genuine change. Well, preferences for doesn't really make sense either, especially because let's say if he had a preference for this, right, he wouldn't choose a switch, right? So the answer should be this one, just out of process of elimination here, right? But even if you didn't know this, see, we were able to figure that out. Now, incongruities make sense. Incongruities means a difference. It means a change, something like that, some sort of difference, right, between two things. Here we're comparing this and we're comparing this. Okay, and we have a genuine change, another change, right? So what we're trying to look for here is a word that involves some change. And that is how you solve a words in context. All right, topic 8, text structure and purpose. This is one of the most important skills that will show up on your SAT. Guaranteed these questions will be on there. There's only 2 question types, and I guarantee you there will at least be 1 or 2 of these questions on that exam. So question types here, we have which choice best describes the overall structure of the text. This is almost word for word on every SAT. They don't really change the structure of this question at all. Now they also have which choice best describes the function of the underlined portion in the text as a whole. Okay, this is also word for word on a lot of SATs. We're going to split this up into 2 different methods, so let's look at the method for this first question here. So the first thing is you read the answer choices, then the passage. Why is this? Because when you're looking at a problem like this, right, what you need to know is how the entire function, how every sentence essentially in the entire passage is functioning. Now, passages in the SAT can be no longer than 150 words. These ones are pretty close to that limit often. Okay. Now, once you read the passage after you're done reading the answer choices, you want to generalize each sentence. Okay. Generalize each sentence, make it like 1 or 2 word summary so you can kind of look back at the answering choices and reference them like, does this match what I'm seeing here? What am I seeing? And this might seem a little abstract, but we're going to go over an example question in a second that should make this pretty simple. Okay, then after you do that, you're going to match your 1-word descriptions to the answer choices, and that's pretty simple. Now we're also going to go over one little technicality here. If you have a question that asks for the purpose is the why. Okay, why is the author writing this? What reason does the author have of giving this to you, giving this information to you? Why is this author including this sentence or that sentence or whatever? The structure is the how. How is the author working to convince you of something? How is the author telling their story? All right. So let's look at an example question here. Studies of consumer behavior reveal that in the minds of consumers, prices never exist in a vacuum. Okay. I'm going to go back and read the answer choices now. So which choice best describes the structure of the text? We know that it's going to be one of these problems here. It's the exact same wording. So A, it presents a study of consumer behavior, then critiques the methods used to conduct the study. B, it outlines an experiment, then it provides details. And again, you're going to see a lot of these keywords when you do one of these questions. So I'm just going to kind of underline the keywords here. So it presents a study, then it critiques the methods. It outlines an experiment, then it provides details. It introduces an argument, then describes an attempt to alter that. It states a finding, then provides an example. Let's read the passage here. Studies of consumer behavior reveal that in the minds of consumers, prices never exist in a vacuum. There is no price, no matter how low, that is always reasonable, because consumers always measure current prices versus historical ones, and against prices of other goods. We might think that 10 cents, which is a quantity of money that most of us have mindlessly lost between couch cushion sheets or on the sidewalk, is always expendable. And it is when assigned to an item that normally costs $2, like a candy bar, but charge 10 cents at checkout for a single-use plastic grocery bag, an item for which consumers are not accustomed to paying directly. And studies show that consumers are repelled refusing the bags about half the time rather than spending their dimes. So, let me kind of characterize this in the one sentence method. So here I would kind of just call this a topic sentence, right? That's like 2 words, but it's fine. So let's call this topic sentence. All right, it could also be, it's kind of like a, if you were to think of a word here, right? What it's saying is it's kind of giving a little bit of a claim or a fact or just basically a statement. Now we might think, okay, what is this sentence really doing? This is kind of providing you with an argument, I would say, right? Maybe an argument. Because it's saying that it's always expendable. We might think maybe it's not. The author is going to introduce that maybe it's not, right? And it is, maybe. So let's say this one I would say is kind of a short sentence. It's not really, it's kind of part of this one, so I'm not going to assign a new word. Okay. And then it says, but charge 10 cents at a checkout for a single-use plastic grocery bag, and studies will show that consumers are repelled. This is an example. This is pretty simple. So I'm going to go back and look at my answer choices again. Let's try to match this up. So it's not presenting a study. That's definitely not true. And it's not critiquing any methods used to conduct that study. So it's definitely not A. It's outlining experiment. No, there's no experiment that we have outlined here. Okay. There's definitely no procedure outlined. It introduces an argument. Well, maybe, but it definitely does not describe an attempt to alter those habits. We don't see that here. It states a finding. States. Well, we had the word statement up here, right? I kind of said the word statement. It's a topic, it's a claim, it's a fact. That's what we're starting off with. Then it provides an example. Have that here for sure, demonstrating that finding. So we can just say it's D. And that's how you want to solve one of those problems. Now let's take a look at a different problem, right? Kind of similar. Which choice best describes the function of the underlying sentence as a whole? So the first thing you read here is you read the answer choices, then you read the sentence, okay? You just read the sentence, and then you read the surrounding sentences. So we're going back to that sentence sandwich, okay? And then we're gonna do it in one word, all right? We're gonna describe our sentence sandwiches. So each of these words is gonna have one sentence description. Our sentence sandwich is the sentence before, the underlined sentence, and the sentence after. Let's take a look at this question from the lightning rod man. The stranger still stood in the exact middle of the cottage where he had first planted himself. Okay. That's just kind of introducing it. Now we're going to take a look at our answer choices here. So which choice, blah, 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 we know what the answer, what the question's asking here. So it sets up the character description presented in the sentences that follow. It establishes a contrast with the description in the previous sentence. It elaborates on the previous sentence's description of the character. It introduces the setting that is described in the sentences that follow. So, first sentence, the stranger still stood in the exact middle of the college where he had first planted himself. Okay, that's kind of just like a description, I guess. His singularity impelled a closer scrutiny. A lean, gloomy figure. This is kind of short, so we're going to kind of extend our sentence sandwich, okay? Because we see that this could be a comma and this, alright, it could be some other form of linking phrases here, and that would kind of work. Hair dark and lank, mattedly streaked over his brow. His sunken pitfalls of eyes were ringed by indigo halos, and played with an innocuous sort of lightning, the gleam without the bolt. The whole man was dripping. He stood in a puddle on the bare oak floor, his strange walking stick vertically resting at his side. So let's try to characterize our sentence sandwich here. So this is a description, right? This is just a description. It's further description. This is kind of introducing that description, right? It's an introduction. It's a why. Right? What is impelling this description? Why are we having this description? Because of his singularity. In the sentence before, it's kind of just introducing us, all right? It's kind of just context. Where is he? What's he doing? Where's he at, right? So I would say immediately, this is A. This is our why. It's impelling a closer scrutiny, and it's leading to this whole rest of the passage, which is our character description. There's no contrast. He hasn't moved. He hasn't done anything. There's no description of the character really here. He's in the middle of the college. In the middle of the cottage, he's a stranger. That's pretty much it. It's not really elaborating on that. It's kind of more elaborating on his looks at this point, right? Introduce the setting. Not true. That's the first sentence. And that is how you would solve any sort of text structure and purpose question. All right, now we move on to topic 9, rhetorical synthesis. So this seems like a lot. Rhetorical synthesis sounds like a complicated topic, but it's really not. Anytime they ask you a question like this, it's going to say, which choice most effectively uses info from the student's notes to accomplish the goal? Okay, and this seems a little bit weird at first because this has never been a question that was asked in the paper SAT, digital only pretty much, but it's pretty simple. So when we look at our steps here, we have read the question, then you read the answer choices, and this is important, you read the question first, okay? Because the question will give you important information, all right? In these cases, the rhetorical synthesis questions, they sound complicated. I would say objectively they are the easiest questions on the SAT. Okay, you eliminate clearly incorrect answers. This is a huge one for rhetorical synthesis because often a lot of the answers, at least 2 or 3 of them, are completely wrong. They're just completely wrong. They don't answer the question. Then, once you do that, once you eliminate questions, you're probably only left with 1 or 2 choices, okay? You're going to validate the info in the remaining answers, so you just read the passage, and that's when you actually read the passage, okay? And then you're going to choose one. Let's take a look at this example question. So, when researching a topic, a student took the following notes. There's a bunch of notes. The student wants to emphasize a similarity. What choice most effectively uses relevant information from the notes to accomplish that goal? This is a similarity. They're both. Both. This is not even a similarity. Okay? We can just eliminate this one straight off the box. This one says unlike. Also not a similarity. I don't have to read the passage. I don't need to know who Charles Dickens is. I don't need to know who Tom Jones is, Henry Fielding, whatever. I can already tell you that these 2 choices are wrong because there's no similarity here. Completely wrong. So now I just need to figure out which one of these is correct. So let's take a look at picaresque novels or whatever. I don't even know how to pronounce it. Doesn't matter. Okay. This one says David Copperfield is a Bildungsroman. Well, only Tom Jones seems to be a picaresque novel. So A is wrong. We know it must be B. But let's see. Both of them focus on the adventures of their title characters. Let's see. David Copperfield, the main character, grows, learns, changes from experience. We're focusing on the adventures of the title character. This one's also focusing on the adventures of its title character with the main character. So we know it's B. Again, these questions are super simple. You can often eliminate quite a few answer choices right off the bat without even reading. Make sure you use the answer eliminator in Blue Book when you take the SAT to just quickly eliminate those choices and get them out of your mind. And then you just need to read the passage, just skim them. You know, it's notes, it's bulleted notes. It shouldn't be hard to skim. So once you do that, you should be all set for these types of problems. Real quick, real easy. All right, everybody, topic 10, cross-text connections is our next topic here. So question types. Based on the text, the authors of both passages would most likely agree on which statement, or how would the authors of text 1 respond to a claim from text 2, or, text 2 to text 1, etc. Okay, these are pretty simple. They're kind of like rhetorical synthesis in that you do have to do a lot of reading sometimes, but here are steps to solve those types of problems. So, the first thing you're going to do, you want to skim passages. You don't necessarily need to read every word. Just make sure you get the general idea. Make sure you know which side of the argument both are on, which reasoning, what line of reasoning they have, etc. Then you're going to eliminate conflicting choices, or choices that conflict with these lines of reasoning and their point of views. Now, remember that the correct answer will extend the author's point of view. They'll extend their ideology. What does that mean? Well, in each text, there's going to be some sort of ideology that's stated, some sort of point, choice, view, opinion, whatever, right? And they're going to back that up with some sort of reasoning. But what your answer choice should do is your answer choice should kind of continue their logic, continue their line of reasoning, right? It shouldn't conflict with it. It shouldn't do anything like that. Let's take a look and just read these, okay? I'm not going to read them word for word. I'm just going to skim them, give you a second here to skim them, maybe see if you can answer the question. Okay, so let's start off with answer choice A. By pointing out that Moore would assert that external world skepticism is at odds with other beliefs that these proponents must unavoidably hold. Okay, and this is how author 1 is responding to author 2. So author 2 is saying that external world skepticism is philosophical stance supposing that we cannot be sure of the existence of anything outside of our own minds. Okay, and G.E. Moore, who is the guy up here, is offering a proof refuting this stance. Okay, and I would say that this immediately is our answer. All right, why is this? Because Moore is asserting, right, that to think about this, right, to even think about external world skepticism, you can't be sure of anything. So to be sure of something, To be sure of anything, you need to have your basis. You need to be sure of something to be sure of anything, right? So I would say this is A. Now, this is pretty philosophical, right? We're getting kind of deep here. But by B, okay, so by arguing that it is valid, if it is valid to assert some facts are true based on instinct, it is also valid to assert that other proofs are inadequate based on instinct. Well, this isn't really what he's offering up, okay? There's not too much on instinct here. The main choice is definitely not on instinct, and this one doesn't even really mention instinct, right? So he's not going to respond to text 2 by talking about instinct when text 2 didn't even talk about instinct. Now, choice C, by agreeing, he's not going to agree. We can just take this out right here, but with agreeing that proponents that contradict his own is fundamentally unserious, okay, that's not how somebody's going to argue. They're not going to say, oh, you're silly, right? So this is not the right answer. Now, our last choice here, by suggesting that an instinctive distaste for Moore's position is preventing external world skeptics from constructing a sufficiently rigorous refutation of Moore. Now, she's calling an obviously annoying failure, right? And they haven't found out how to refute it exactly. But I would say that this is not the answer, right? Because although they are instinctively distasteful of it, right, external world skeptics aren't explicitly mentioned here, right? External world skeptics here are here. We don't know if she's necessarily specifically an external world skeptic because it just says many philosophers, right? And this is not what this author is arguing here. Okay, this is a better answer. Maybe this could work if we didn't have A, but D is just simply not as good of an answer because, of course, he's going to go after the root of the issue. This goes after the root of the issue, and this basically just says, well, if you can't do it, if you can't refute me, then I'm right. Okay, they're going to try to give some more reasoning. They're going to back up their previous reasoning. They're not going to keep saying, you know, I'm right and you're not. That's not productive argument. So that means that A would be our better choice here. All right, we've got boundaries now. We're moving on to standard English. Okay, which choice completes the text so that it conforms to the convention of standard English? You're going to see this phrasing a million times on the SAT. It's guaranteed to be on there. These are just some of the things we're also going to get into form, structure, and sense, but this is boundaries. So first thing you need to know is your types of clauses. So you got 2 types of clauses. You should know this, right? This should be common sense. This should be common knowledge. Independent and dependent clauses. So an independent clause can stand on its own. So something like the man and the dog went to the park. All right, this part here is an independent clause. But this part here, the dependent clause, is where they played catch. If I just said where they played catch, it doesn't make sense. Okay? Like, just think about it. Think about it in your head. It doesn't make sense. You wouldn't say that, right? So a dependent clause is something that requires some other clause, some independent clause, to kind of qualify it. So it makes sense, right? The where is now answered by to the park. Now we have to link clauses, right? We have to link our dependent and our independent clauses. And how we do that, there's quite a few ways. So the first thing is end punctuation is kind of just like a qualifier for any of this, right? You need to make sure that if you're asking a question, if your sentence is asking a question, it's going to end in a question. Or if you're making a statement, it's in a period or an exclamation point, right? If you're making a command or something. Okay, that should just be common sense. You should just, have that all set. Now, coordination is our first way that we use to link independent clauses, and we need to use fanboys. What's fanboys? It's an acronym for and, nor, but, or, yet, or so. Okay. Now, we're going to use this formula here. Okay, and you should memorize these also. Independent clause plus comma plus fanboys plus another independent clause. Okay, this is how you link using the coordination skill. So you have a first independent clause, then you add a comma, a fanboys, and another independent clause. So let's say we have our first here, this is an independent clause, comma, this is one of our fanboys, then another independent clause. Let's look at subordination. We're going to use to link independent clauses again, but we're going to make a clause dependent by doing a subordinating conjunction. So we have a subordinating conjunction, an independent clause, a comma, and an independent clause. Although it was raining, think about it, on its own it doesn't really make sense because you need to say something else, although what, right? It doesn't make sense. Comma, the sun was still shining, another independent clause. Lastly, we got our semicolons here we're going to use to link independent clauses again. Semicolons are the easiest one. You just have to have an independent clause, then a semicolon, is your space, and then an independent clause. So ice cream was well scented, semicolon, the air smelled like chocolate. Now we have supplements, or otherwise known as elements. Okay, Essential elements are necessary for this sentence to make sense, and they don't require any separating punctuation. A non-essential element is separated from the rest of the sentence by either a comma, or 2 commas, a pair of dashes, or a pair of parentheses, right? And the sentence still makes sense when a non-essential element is not there. But if a sentence doesn't make sense when something is missing, it means there was an essential element. Now, if you have a non-essential element at the start of a sentence or at the end of a sentence, you just separate that using 1 punctuation mark. For example, a famous president, comma, Abraham Lincoln, was known for presiding over the United States during the Civil War. If it's in the middle of a sentence, you separate your non-essential element using 2 punctuation marks. Again, must be a pair of dashes, parentheses, or commas. So I could make this parentheses, I could make this commas. Okay? They're only going to give you one option that's correct. So this also must match this. I cannot have a dash and then like a comma. It just doesn't make sense. So Abraham Lincoln, a famous president, was known for presiding over the United States during the Civil War. Lastly, here's just a brief punctuation guide. Commas can be used to separate lists, to separate elements as we saw earlier, and to link those clauses together. Colons can only come at the end of an independent clause. They can either provide an explanation to something, or they can just, give you a colon and then you have a list after that. So you have a list. Okay? Dashes are used to separate non-essential elements, as we discussed, and that's pretty much all you'll need to use dashes for on the SAT. And that is some basic grammar. We are rounding off our study of topic 12, form, structure, and sense. This is just the basics of SAT grammar. This is the final topic that we're going to go over here. So let's start it off with some subject modifier placement. Subjects must be next to their modifier. So if we have a subject of a sentence, being asked to write an essay on metaphors in Moby Dick, the white whale for which the novel is named, was a topic chosen by most of the students. Students here is our subject because who's being asked? The students are being asked. Okay? So what's the answer? Well, this is our modifier. This first sentence is almost always the modifier. What's our subject? The students. I mean, students must go right next to it, must go right here, and our answer is D. Okay? Now, for our verbs and our subject-verb agreement, we're going to try to keep all of our sentence and passage. It's got to be in one tense, right? We can't have, some parts of the sentence is past tense, some parts is future, whatever, whatnot. All right, and we also need to conjugate. We can't say like they was, it's they were, or, he were, right? He is or he was or whatever. All right, got to make sure that that's correct. Now let's take an example question here. Reading fiction, cooking from scratch, and spending time in his garden is some of the ways that Frank relaxes. No, it doesn't make sense. Just think about it in your brain for a lot of these verb things here. Like, does that make sense? Is that the right grammar? If you are an international student and these conjugations are a little tough for you, try looking up some sort of conjugation chart and memorize that before you go any further with your subject, verb, and your verb agreement. But the answer here is R. Okay. This is present tense. He's currently doing the relaxing, right? They are some of the ways that he relaxes. They is not some of the ways that he relaxes, right? They are some of the way. Okay. Your pronoun antecedent agreement. Ensure that pronouns are accurately pluralized. It's basically what this is, right? So, though Dorothy's shoes were red in the Wizard of Oz books, it was changed to red in the movie. It is not an it. There were multiple shoes. So I would say they were changed to red in the movie because they were. It's a plural. These wases don't make sense, right? And she was makes even less sense, right? This doesn't really agree. The shoes are not a she. Okay, English is not a language where nouns are all necessarily gendered. And our last bit here, this is the last part of SAT English. We're at the end here. Plurals and possessives. So plurals require no apostrophe. Right? When you pluralize something, you don't need to add an apostrophe. Never, ever, ever add an apostrophe. Even for an abbreviation. Let's say you're trying to teaching assistants, TAs. It is TAs. There is no TAs with an apostrophe. It's just TAs. Okay, you never, never add an apostrophe. All right. Now, singular possessives. Your apostrophe plus S. Okay, when you make something possessive, right? When something is the company's, okay, say like the desk is the company's, you add an apostrophe S. Okay. Plural possessive, also apostrophe S, unless it already ends in S, okay? This also applies for this rule. So let's say we have, Vice President Kamala Harris, right? Harris. When Harris has something, you just add an apostrophe. You don't necessarily add an S. Now, in some newspapers, like the New York Times style book, they still add the extra S. But conventionally, we do not need to add the extra S. This is a unusual thing that the New York Times does with their style book. You know, AP will not recommend the same thing. Take a look at this. A boa constrictor can give birth to dozens of live young who will first develop inside they are. Is what this says here, right? When we expand this. Mother's body protected from predators. This is a usage of the wrong there. Wrong there. Okay, it's the wrong one. All right, they are. It doesn't make sense. Just think about it. You know, expand the contraction if you need to. And if it still makes sense, you know, put it down in the comments. Make sure that we know. All right, if you need more help with all the different theirs. But which choice modifies the underlined text so that it conforms to the conventions of standard English? Our typical question. No change, no, because we know this there cannot be correct, so we can just eliminate that right off the spot. Their mother's body. Well, whose body is it? The mother has possession, all right? The mother has possession. The mother has the singular possessive, so the mother should have apostrophe S. Okay, it should not go after. That doesn't make any sense. It should be apostrophe plus S, which we see here. So the answer is D, and that is the end of SAT English.